Hello everyone, welcome to another stream. How we're doing? So, last stream we were carrying on working with the fractal noise virtual machine thing we got in the shader. So we're doing this because we want to make a sort of a build time shader which allows us to like procedure generate different materials. This is the sort of first two that we made from just a bunch of different fractal noises, and we've been just exploring ways of making it easier for someone to use who's not a programmer, basically, and quicker to use. So we're going to be making like a material, a way to edit these materials in the game, and there'll be like sliders and things, and you know, ways to pick a particular color with like a proper color picker and everything. But yeah, and then export those as actual materials and save them out such that they get built as part of the build system. Hey there, Geeko, how's it going? Not doing bad, thank you. Yeah, I got the new haircut. Yeah, did that yesterday. Kind of went and sat down with sat down at the hairdressers, tried to spark a conversation, and the guy just didn't clearly want to talk, so I just sat there in silence. You know, like, yeah. But I got my hair cut, which is good. So, yeah. Hey, Myvar, welcome. Welcome, sir. Welcome, guys. Thank you. Yeah, that's right, isn't it? Yeah. Also, the beard is nice and trimmed now. So, my face is actually a lot more narrower than it appears to be. My big beard. There we go, music. So we're just going to hopefully finish up on that fractal noise virtual machine thing that we used to generate materials today. So we'll have the shader basically done, and then we can move back on to just getting yeah, probably make some tweaks to the material system and then go back towards getting the editor up and running. So last stream I started making some changes at the end to this. We're having like a layer thing. I ain't doing that anymore, are we? In layers, we're doing that. Yeah, it's a bad idea. We're not doing this. It was too structured. So to make it all into instructions. I think I want to make this into another structure. I forgot we want to make this into like a... We'll leave that. Might call it like a shade or something. Yeah, so I sort of broke the shader build a bit. We'll get up and running there in a sec. So I used to have these color edges at the end, each of these. So take the final noise value and turn it into one of the textures, basically. Like, give it a color. So on the Discord, I did post about it up here. We probably want like a color gradient instruction for the virtual machine, which tells you how to produce a color based on the noise on the top of the stack. And then it can do blending, and then you could get layers as well, which would be interesting. That could be pretty cool. It'd be pretty powerful. around these parts, the barbers always mess up my style. So I got a hair place. So I go to hair place for ladies. They do a much better job. Right. Right. Yeah. Yeah. I think when you get like a female cut your hair, typically they will have gone through like lots of training, and they would have they have they typically have like their own place basically at a salon and stuff like that. Whereas like yeah, I think in the UK, like if you go to like a barber's, typically sometimes like anyone can just get a job there basically. But they would have to get trained, but they wouldn't have necessarily gone to maybe like a school or something. But yeah, it does make sense. But yeah, so we're gonna add a new instruction called like color gradient, which will take the noise value off the top of this noise stack and then color it. And that allows you to do layers. So we'll be able to get rid of those poles and stuff like that with an alpha mask. So it actually takes two distances off the stack. It takes one for the height. Well, I said distances. It takes one value off the top of stack, which we'll use for the height, and another one which is the alpha mask. So yeah, this can be, what do we call this? This is yeah, maybe those just go into an anonymous strut in the op. AC, I don't know. What's that color? Oh, color space needs to go in here as well. And I think we might want to maybe say you might only want to apply some of these. And yeah, I guess you can do that with all this. Right, color edge. There's just so much damn. Constant should always go at the top. Put it here. Right. Cool, so we finally got this. Oh, I missed it. Where is it gone? It's not a chord space. Where did my color space go? The color space. Why is it called a lerp color space? Oh, I've already got it in here on each of them. Perfect. Right, so that's another instruction. Color grad instruction. So let's add this in here. So this is a way that you color at the end, basically. Color grad. I think I'll also want to add the ability to PAL and probably do the inverse PAL. Oh wait, what will be that? Yeah, just 1 divided by, that'll be right. Hey Perry Perry, how's it going? Yeah, exactly. Yeah, you can learn to cut hair. It's probably not too bad, or too hard, is it? Like, I've got to the point now where I can shave my beard without a template. So I just go around it with a, yeah, and I can get it to the level I want. I did try to cut the, when I had some dogs in the past, and I tried to cut their hair. I did quite a reasonable job for the first time, I think. I find what every time I go on Discord, like, here it is, Discord on the half. Right. Yeah. Yeah. I don't know. I think what's interesting is what you'll find is that that's of the people who are. So it's interesting. So you've got people who are social and who sort of actually talk on and they go on Discord or they go on Twitter or whatever and actually talk. But some people only sort of talk in certain Discords or certain places on Twitter, right? And then you've got people who literally just lurk, right? But are on social media. And then you have people who don't basically do any social media and just work at a day job, right? So there's kind of a spectrum of it. So, and I think quite a lot of people don't use social media. I think that's quite a big number actually, or at least they'll just lurk a bit, but they won't be on it all the time. But yeah, it's kind of a small world. There's a lot of people in the sort of who use it. I say there's probably 10 times more people who, or maybe more, basically use Unity and Godot, and maybe you can class the Unreal people in that. But the Unreal people tend to be more people who will sort of get into the source code sometimes. There's kind of a two communities there. I find I isolate between interacting and lurking for months at a time, as I will as I have the power to deal with people. Yep. Noise there. Get rid of that one. Cool. So, right, these are the inputs. Basically, in the editor, we'll just have an array of operations, and it's just a stack-based virtual machine where it pushes on like a simplex noise or a Voronoi noise, and then you can sort of like operate on the operate on those values basically that just get populated per pixel. It's not designed to be super fast, but it's definitely going to be faster than running it on the CPU, and it will run pretty well at build time. Oh, for building materials, it's going to be pretty ideal, and in the editor when you're sort of editing stuff live. So, yeah. This coordinate space is going to be useful for simplex and Voronoi noise. So what I would like to do, or Voronoi, I don't know how you pronounce that thing. It's French, isn't it? So I'm probably pronouncing it incredibly wrong. So we should probably, I've got FBM. Yeah, I'm going to put it in a strut like this. So every time you make a simplex or Voronoi noise, you can say, hey, what coordinate space do I want this to be in? Do I want it in Cartesian? Yeah, that's how you pronounce it, and then spherical. Okay, beautiful. Right, so let's get back to the actual shader and fix all that up. So I've got this sort of grad eval. Okay, that seems all right. Grad.lerp color space. Yeah, that makes sense. Right, there's my little simplex noise. Oh yeah, fractal simplex, fractal Voronoi. Here's the shader, the sort of test shader. So Right, this is where the virtual machine 1 begins. Perfect. So let's get this thing back up and running, and then we'll add our edits to it. So there's no longer a coordinate space thing here, although, so what we're going to produce is a sample point in a Cartesian, that's how you pronounce it. I forgot to put the R in there, even though I pronounced it that way. Then we want to have a sample point spherical. And then what we can do is start off in, yeah, we'll just leave it at that. There we go. So now we go over all the operations, and here's our stack. So we can probably just rename this to the value stack, I reckon now, because it might not just have noise values on there, it could have other things. But, so we'll call it a value stack. Let's go over all our instructions. So yeah, it's just a stack-based VM. We've all seen these before. Done on the GPU because it's going to be fast, hopefully. Right. So I've added 2 new instructions. Oh wait, let me just finish this off. Cool. We've added 2 new instructions. Let's get the easy ones out of the way. So I added pow and inverse pow. So pow's going to take 1 instruction off the stack and then put a new one on, which is the is pow with an immediate. So we need 1 value on the stack. We'll get the value off. We don't bother taking it off. Then we pow. Then I think this will be operation dot right, so you do, so we'll figure out what to call it. Yes, let's just call it power, isn't it? So it's the base value then power. Okay, good. So we'll call it power. Nice. And then we'll have inverse power as well. So what this will allow us to do is if we have like a noise value and we want to treat it we want to convert it into something which is not linear, which will allow, just, yeah, it's flexible. And then this will just be an inverse of power. And the reason why I have inverse of power is because in the UI, it means I can have a value which starts from 1 and goes from 1 to 8 or something like that. And then I can have a value which goes from 0 to 1 and have a different slider and not have to bring it to 2 different sliders maybe. Something like that. That's the only reason why. Maybe the UI could feed out to the same instruction maybe. But oh well. Bruno was Russian and Ukrainian, not French. Was it? I swear I googled it and it said. It is Russian. Okay, my mistake. Interesting. There's too much credit to the French, eh? They do a lot of things. Nice. Amazing. Thank you for the correction there. Hey, I'm not doing bad, thank you. Yeah, I'm just a little bit tired. That's about it. I haven't got the best sleep lately, but I'm doing all right. Doing good. Excited to wrap up on this bit of work here, I think, today, which would be cool. And then move on to just back onto the materials in the renderer, just fix them up a little bit, just wrap that up before moving on to making a material editor for this, which is cool. So I think we'll probably make a bark today, a bark texture with this, a very, very terrible one, but just to show that it's capable of doing it. We'll have support for layers and things like that. So like basically layers of materials that you can blend together. So yeah, it's going to be pretty powerful, this little shader. Hope you're doing good, Peri Peri. Hey, Seven Artist, how are you doing? Welcome, welcome. So the other instruction I wanted to add is, okay, I need to add that power thing to that. So here's the things: we don't have unions, and since it's just a build time shader anyway, I don't really care that much about, you know, packing stuff. This operation is just going to be in a structure here, even though we could switch on it based on the opcode. Doesn't really matter that much. What could be the immediate value? Yeah, we'll do that. Okay. Radio. So the final instruction to add is the gradient, color gradient. So what this is going to do is take the value off the top of the stack and then color based on that value. So what I'm going to do is hold, so albedo, emissive strength, messiness, roughness, they are already variables, and we'll probably have a yeah, I gotta be careful. Yeah, so we probably want two values, right? We want A and B. So this would be the height, and then this will be the mask value. So you put the mask on. And so that's something we probably want another op actually, just to push on an immediate. Just a push basically. Probably just a push and a pop. Because you might, why would you want to pop? Everyone is will consume. Probably don't need a pop. Just say push immediate. And probably be a good one. So push immediate is just gonna, where's all the ones that push the value back on? Put these ones up here. Or just copy the whole thing there, to be honest. So I just push on op.immediate. Nice. Right, so we need a way to store like a color. We have like albedo, emissive strength, maleness, roughness. So I'm thinking, I was rather tired for the past several weeks. I've been playing with shadows. Didn't realize how big of a topic it was. Interesting. Which do you like shadow maps? That sort of thing? Or are you looking into more of the recent sort of direct more of the direct lighting, like ray tracing? There's also other types of shadowing, right? You've got stencil shadows and capsule shadows and, you know, sign distance field based shadows, array marching. So I was thinking we should add like a blend mode. You know, maybe let's just get this thing working and then we can worry about like doing this multiple times maybe. So essentially I just want to move this here. We won't bother using the mask just for a second. If there's an error or albedo dot a is I don't know. Let's just say there's an error then. Yeah, just color it with that error texture. Okay, hopefully this gets us back up and running again. Right. So this stems from color grad. All right. Hang on a second. I need to add our new instruction. Alrighty, so we take that, put it down here, and that is right. So on two instructions to do the Voronoi noise, and then we just color at the end. Now the problem is we haven't got .ops. We'll put this as at 2 actually, and the reason is because we want 3 instructions now, and we would like to make it such that this one would be store immediate or push immediate, and we'll just push on a 1. All right, cool. Let's give that a run. Did I do that in the wrong place? Oh. Right, I realize I've got submaterials. This is my... Let's try and get the submaterial working first and we'll get back. Right, sample point. Okay, so based on the... Effectively, we need to make a new local called sample point. And if operation dot coordinate space is equal to noise coordinate space Cartesian, then we'll get the not spherical coordinate. And do the same thing for the Voronoi noise right here. Neat. Right. Right, input, so that'd be ops. Op dot color grad. So gradient. Oh. Shader compiler bug. Joys. Sorry, we'll find it. Implement shadow mapping for directional spotlights and cube map. Shadow mapping for point lights. Nice. They work fine, but I have trouble creating a scene with multiple lights and multiple shadows that blend with each other nicely. Yep. Also got interested in cascade shadow mapping and shadow volumes. Not such in ray tracing and path tracing yet. Yep. Nice. Yeah. Yeah, it's pretty nuts, isn't it? You basically render a depth map for each light. Yeah, it's cool. Yeah, I think with cascade shadow maps, you got like cascades of them. Yeah, I don't know what I'm doing for shadows yet. I want to see if I can get away with just rain marching them. But yeah, that's for a future date. I don't know what I want to do yet. So yeah, we've added something which has caused a bug. So I reckon it's the data at the top, basically. But what I'm going to do is comment out these if statements just to see if these are the right. So it's still happening. So I think it's these here which have caused apparently not. Oh, type deduplicate. Oh. Yeah, okay, so it's to do with the types. So something to do with these types up here that we've changed. Could be this. Has my anonymous structure... Yeah, I think it's... Okay, I think it's this because it's anonymous. I think I broke that code then some time ago. It was working before. Let's just double check it. We can go and fix that in a sec if so. And we didn't put a... Yeah, that compiles, didn't it? Okay, so there's like a bug in the compiler to do with... Right, and then that doesn't even want to work. Right. Let's go and fix that because I want to be pretty easy. So the bug in the compiler is in SPIV when it's deduplicating the type. When we make a structure, there's a name. It expects an ident to be there, right? Where I do the type information. Alright, let's go back to here. Let's give it a run. Right, 1870. Oh. That's BBJ. That's why I wasn't finding it. Oh no, that's core. Okay, 1, 2, 1. Yeah, something seems off about this. Yeah, so it's in 18. Let's go to core 1870. Just Pushing on a stack. Call stack appears to be off. I think this call stack's a little bit corrupt. Okay. It's same for an array. So it seems like it's doing this sort of array push basically, but it's the error is different. It's supposed an ID to be a non-zero value. What is to do with the names? So let's find where the names are. The structure has an identifier in it. So let's look for this identifier string ID. I think this is it. Right, this would be it. I think. So if it's a compound type, go over all the storage fields, and we do, string table get on an identifier, right? So this is obviously a problem. This is if it hasn't got a name. So what we need to be able to do is just say if. So I think maybe we could just, we could give it a name. I can just call it unnamed. And then like, yeah, like what is it one? Is it like a, okay. So what we'll do is we'll have like a char field here where we say like, let's call it buff, I guess. Do 16 characters. And we'll say if, let's have a string here. Let's call it name. So if this is equal to 0. All right, let's say if it has something, this is what you get. Name is equal to that, else sn printf into buffer, and simply just put in unnamed with an index, and we'll just put in the field index. Yep, so at least this won't just be a random thing in the SPIV assembly, it will just show up as unnamed. That. And then we'll make sure that name is equal to that string basically, and then add that member name. And that should be the fix. It was crashing in a different place apparently, but I think that's the place where it's actually crashing. So we give that a quick build, and then I've got a copy that I could copy it over like that, and then just give it a run. Right, it doesn't seem to be crashing anymore in the compiler, so yeah, there we go, we found the fix. Cool, so let's get this material shader back up and running. Let's do a release build, so it's going to be faster. I need to remember to commit that. So I'm going to leave a tab open. So I'll commit that after the stream. Cool, so now it doesn't really work. It's got a black screen for some reason. So we need to figure out why, right? This should be running. So it should be doing a Veroni noise, push on an immediate of 1 for the mask. And then Right, so this is missing the coordinate space. Cartesian, there we go. I don't know if we're missing anything else really. Oh, that wasn't the right opcode, is it? Right, color grad opcode. Speaking of shadows, I was playing some of the Witness and I really like how shadows are done there. During the game, it's beautiful. I've not really noticed the shadow or what the shadows look like in Witness. But yeah, that's cool. You should maybe investigate what they do there. Maybe see if there's like see if there is a review of the renderer in any way posted up. Because people like to do that, dissect renderers of games. Of course, this is the material that we're generating inside of the shader with just these instructions here, right? We've got the Voronoi noise, which generates these sort of cells. Then we push on a media which is not really used at the moment. Then we color the noise result on the top of the stack, basically, right? With these values, and that gets us this sort of material, which is quite cool. And we can edit this live. We can change the scaling. And then it changes live, basically, which is pretty cool. So let's go ahead and so leave that one alone. We're going to go to submaterial 2 because this is the one, or 1, right? The second one. Because this is the one that we were actually, I was keeping this one just as a way to, it was just keeping it around just so we can always switch back to it. This is the one we was using to edit. So we're going to be trying to make this one, we're going to try to achieve the wood with this, basically. So let's try and get the precursor to the wood up that had the poles, where it kind of looked funny, because you did it in spherical coordinate space, didn't we? Something like that. And the multiplier, why has it got a multiply? So this has got the sort of wood colors, basically. They're horrible colors, but kind of wood colors. They will do for now. So we need to add ops to, I think, dot color grad. Nice. Voronoi. I need to add another one for the coordinate space. This one uses the coordinate space of spherical. And then we're just going to use these FBM values here. And then I would need probably to push an immediate as well for now. And the immediate value would be 1. Okay. So let's see how well that works. Oh, I didn't put the opcode in this one. Color grad. All right. Yeah, so we get that sort of pole at the top here where it just all goes around really fast. Closer and closer it gets to the top, it goes around really, really fast, right? The X value. the X value goes around the outside of the sphere. And obviously the X value is gets quicker and quicker and quicker as you go closer and closer and closer to the top. There's also this seam here as well, which we've got to try and get rid of, but we're talking about the poles at the moment. Well, we could have... yeah. So if we change the scale... so we change the scale on the Y. Yeah, no, create something like looking like that. Where it stretches it across the Y. So maybe get up it to like 32. Maybe the white isn't really a good color, but anyway, you see the point we're trying to make here. Now, there is that seam there, I think. Don't know if you can see it going down here. Maybe there's not one. That seam just kind of... yeah, there's a clear seam going down here. Even if we had it at 1, the seam is still there, isn't it? It's because it just repeats. So the way we got rid of that is that we mirrored it. Something like that. Yeah, I wonder if there's a way we get rid of it. But let's just try and get rid of these poles with the new instructions. So the ways we're able to do it is, I was thinking we could take... so I was thinking we could do with the existing thing of adding 2 layers of materials just by pushing 2 different Voronoi noises and then add in this sort of like... oh, add in a smooth step instruction and a way to sort of push on a dot product with a normal. Yeah. And with these instructions, you should be able to isolate the top and say, basically blend, this could be our mask. Where the mask, wait, what would it be? Right, 2 Voronoi noises. You've got, yeah, 2 edges. Yeah, the result of this would be the input to smooth step after this edge 1, that'll be the X value, right? And then you lerp, and then you do a lerp. Yeah, right. So this pushes on a Voronoi noise to the stack at 0. This pushes it onto stack at 1. This pushes it onto the stack at 2, right? The dot product with the up vector of the normal. So this means that you're going to get a sort of... it's going to be very white at the top, but as the normal changes and gets more and more perpendicular, it gets grayer and grayer until it gets to black at the halfway down. Then we can use smooth step to basically isolate it at some boundary where we want it to stop. In between the top and middle, basically, we can get it more of just up to here where it starts to get really bad. And then we do a lerp. So smooth step will remap it from this 0 to 1 value. We can pick a point to remap it between 0 and 1 at some sort of boundary that we want. And then we can lerp between those. Lerp between, so smooth step will take a value of this value off the top of the stack, and then just put another one back on, and then we'll lerp the 3 values that are left on the stack. Makes a ton of sense. Okay. Let me just check on the boy. I'll be 2 seconds. Alright, welcome back. Everything's good. Right. Yeah, so should be pretty achievable. I guess just add those extra instructions and get something tested out. So yeah, this would be cool. Oh, what am I doing? Just close that one. Let's get the music back. Right. So let's go to these are all the opcodes. And we need to add smooth step and this sort of dot product with the normal. So smooth step. And then I want another couple, which is like basically dot normal and a dot normal absolute. Or you could probably push another instruction, which is absolutes. Well, if I did a dot product with a normal, it gives us like a signed value. Aren't they always unsigned on the... Yeah, I always make them unsigned. So I think maybe the dot product, the dot normal will always produce... Yeah, we don't have any signed values at the moment. Well, it's capable of doing it. It's possible. Let's just add the one with ABS. Okay, let's get these ones in quick. So, we would like to add smooth step. So smooth step is going to take one value off the stack and put one back on. Smooth step for 32. It's going to take op dot immediate 1 and then immediate oop. I'm so used to typing oop. And immediate 2. It's immediate 0 and 1. Because we're programmers here, right? Okay. So yeah, it takes... So immediate 0 and 1, they're the edges, right? So where is it going to begin at being 0? And then when is it going to end up being at 1? And then we pass in our value that we got from the stack, and this is the value that's being tested against the 2 edges. And then basically a value between 0 and 1 is returned here. Cool. Now we want to do the dot product between... This is going to push on... So we'll call it, let's call it a vec. So it's just a vector direction, I think it will be. Yeah, okay. So we dot with a normal. So do we take a value off the stack? What are we doing? No, it's just pushing one on, isn't it? So I need the ones from up the top. They're just adding a value to the stack because I've got that error handling in there. So all we're doing is we're doing the dot product between the normal and whatever is the vector it passed in with the instruction. So with these now, we'll be able to basically get rid of those poles, right? So if we get up and running, so we've got something visual, we can edit this in. So here's that texture here, or we just sort of stretched it along the Y. And we want to try and get rid of these poles at the top because we're using, because in this particular case we're using spherical coordinates, but we don't always, right? But it's because we can get it going all the way around, and I want to be able to blend it with another. I want to be able to blend it with another noise. So we'll get the other noise ready. So the other noise would just be, let's just push on another Veroni noise. This time we're going to use Cartesian coordinate space. So we're just going to up this, oh my days, like so. And then beautiful. So there's 4 of those there. And what we're going to see is just the result of this one, because this operation takes the top 2 off the stack. This is the mask, and this is the latest heights noise. And then it will give us something like this. It is stretched along the Y though. Let me just quickly do this. And this is another way we can achieve it. We've got some other poles here as well though that we might want to try and get rid of. Try for that one as well. Right, so this is the other type of noise. We probably do want to scale it up a bit because we get a nice blend that way. Here we go. Yeah, it does look like a hair. Definitely looks like hair. Yeah, I've been doing it for, started the project on stream and did a bunch of test rendering, or test renderers basically. That's where a lot of the R&D went into. So if you add up all the time, it's only been about probably 6 to 7 months to full time. Depends on how you measure it. So it's quite all right. Like I've settled on what I want to do for rendering now, basically, in terms of I'm just using ellipsoids. I was just monkeying around with lots of different ways of rendering spheres and how to render them, trying to figure out which was the fastest in compute only. So I want to try and blend this one with this one here, which we had before, which was that sort of very fine one. So we can add 2 more instructions on. So you put the 2 Veronis on, right? Then you put on the dot product. So let's just try the dot product and you see why we need to smooth step at it in a sec. So we did the dot product with a vector, and we're going to call that the up vector. So, then we need a lerp. So this pushes 1 on the stack, pushes another value on the stack. This pushes another value on the stack, and this takes 3 values off the stack and returns 1 onto the stack. So when you lerp, I don't think you pass in anything. Yeah, it's all on the stack. See, it takes 3 off the stack and puts 1 back on. No, that's wrong to me. It should take 2 off. Yeah, that was wrong. But it's been corrected now. It's good. Right, so lerp needs nothing. Hey there, Machine Knob. How's it going, sir? Welcome. It's been a while. Hope you're having a good weekend. Yeah, it's just, you know, it's a multiple reasons why this project makes sense. So, one, it gives me something to do and learn in my spare time. Like, you know, I don't, as much as I do learn stuff at work, I don't learn necessarily all the things I want to learn. So I get to sort of do that here. And I have a lot more sort of like, I'm not doing it in an environment to sort of like get my task done. Right, I'm doing it to mainly have fun. So there's different sort of, you know, and, you know, I can also, I work in terms of like, the project is, you know, is basically controlled by someone else, whereas here I get sort of say over this project. So there's that reason too. There is, you know, hopefully in the future this project turns into some other form of like, yeah, hopefully, or this could be a potential career advancement by doing this project in some way. You know, it could help me get a job in a situation where I, you know, need to show like something on my portfolio. But also it could end up being my job in the future. There is, you know, I also get to sort of like share stuff I do online and people can get inspired by that, which is another good one. There's tons of good things about, yeah, just sharing the progress online and doing a project. And yeah, I completely forgot. There's a few more that's floating about. But yeah, maybe I'll remember it. Give me a flashback to my fourth phase in my teen years now forward. What is fourth phase? Oh, right, yeah, the programming in fourth. Is that what it is? Is that a thing? Yeah. Thank you, Batman. Appreciate your appreciate your work ethic too. All those weights you lift throughout the day and to maintain that physique must be hard work. The stack concatenating, right? Yeah. Stack VMs. Yeah, plenty of yeah, plenty of good reasons. Plenty of good reasons to be doing it. So yeah. Maybe I'll remember some other things about it. So, right. Push 1 on the stack, 2 on the stack, 3 on the stack, lerp. Gives you 1 left on the stack. Push another immediate on the stack. And then the final instruction will take 2 values off the stack, 1 being the mask and the other one being the height. So what we'll see is that this texture will be at the top and that sort of hair looking texture will be at the bottom. So let's go ahead and see how that looks. Yeah. There we go. So we've got the blend. So see how it's got this at the top for definite, and then it's slowly fading in the other texture because all it's doing is fading the height, and then at the end it's getting colored, right? So this is not 2 different textures being colored and then layered in. It's just 2 different noise values being lerped together, right? So now, and it's doing that both sides. It's doing it at the bottom as well, but ain't got any light. Oh, No, it's not in the bottom because I didn't do the ABS. Let's correct that. Yeah, I want to do the ABS. Right, so that'll correct the... Yeah, so now it's at the bottom as well. Cool. So now where the smooth step comes in is it basically changes where the lerp it changes the t value such that it is only between 0 and 1 at a smaller area rather than from here to the middle. If we're going 0 to 1, we can get it into a smaller range, and it'll be 1 afterwards and then 0 before it. So we'll add another instruction and we insert it after the lerp. And that is smooth step. And with smooth step, we'll pass it in, so 2 edge values. So the edge, so let's say it's at 0.7 to 0.8. Now we're on that. So now we should get rid of the, oh, for crying out loud, what has gone on? What have you done? So we let, okay. I did the lerp first. I'm smooth stepping the result of the normal. There we go. Right, so we've got this so we've got this sort of, so we've got the Voronoi noise in Cartesian space at the top now, and then sort of towards the middle, we purely have this Voronoi noise in spherical space, which is stretched along the Y, and there's a smooth blend between them here. Now what we can do is we can move that a bit closer to the top where the poles actually happen most. Yeah, where the pole artifact happens the most. And you can get a nice blend like that basically. And yeah, so probably do something a little bit nicer at the top, but this is just an example of it working. So it's pretty powerful. Does your day-to-day involve much rendering at work? Yes, I am a graphics programmer at work. So I, work on the graphics engine or do graphics features. So yeah, and there's like about 4 other graphics programs. So yeah, work is distributed amongst everyone else. The many reasons to go and do something, doing it consistently is a whole new thing. Yeah, true. I think I just have a very sort of particular mindset, like, I keep to my schedule where I work out as well. I'm quite thorough with that. I think it's something I just sort of got to grips with when I was a teenager. Is just doing stuff, just getting hooked on stuff. But yeah. I just like trying to do hard stuff. I think that's what it is. I think that sort of happened as a teenager. Not sure exactly what happened. Somewhere there's an engineer that worked on drivers or chips in your GPU. Turning the grade because of a stack virtual machine running on this architecture. Yep, exactly. But it's purely for build time, I promise. It could be, all I got to do now is make a node graph and then compile it out to this stack, and then, you know, and then it'll be used for everything, for more than just noise, and then we can use it for, yeah, no, let's not do this. Doing it at runtime? No, that'd be terrible. To the scales, it's fairly good. Yeah. Maybe, just maybe. But yeah. So I don't have to make it look good to solve problem. But yeah, if we bring this one down though, we'll see a seam more, and I don't know what to do about solving this seam, to be honest. There's a clear seam that gets shown right here. But maybe it doesn't matter. I don't know how to solve that in spherical space at the moment. I've tried to do the mirror repeat. But yeah, maybe we get that damn seam. Maybe it's not that visible from far away. Maybe it'll just be fine. Both the Cartesian, yeah, you could do it. It just won't look as good though. Oh yeah, so you'll get that different type of one. Yeah, so if you stretch it this way, you'll get, so basically like if we, can I change the blend? Yeah, that was it. So if I up this to about 16 or something like that. So if you stretch it along one axis in Cartesian, this is this first one here, and this is that second layer being blended in at the top. This is where it gets blended. It looks fine and everything. You know, if I remove, where's the blend? If I say, if I just put it at 1. So yeah, this is how it would look if you don't blend in anything. It sort of has that look. So you could then, you know, theoretically, like, I guess, stretch it. Let's go to the other noise that's being produced and stretch it along the X, is that right? Yeah, so you get it that way. And then you can basically blend the two together. So we go back to that 8 and 9 mix. Yeah, so you can blend two of them together like that. That looks pretty alright. It's another way of doing it. You could probably make it a bit wider as well. Do go to 7, 8. So the other way I wanted to do it was, yeah, that's pretty cool. So this is what I was trying to achieve before, basically. So that's all right. Obviously, we want to switch it the other way around, make it more vertical, but let's say 16 and then 1. Let's try that out. Should flip it the other way around. Got to change my normal. Okay. No. Wrong axes. There you go. Yeah, that should go up now, basically. There you go. So that's another way of doing it. It'll go round. It goes round it though, like that. It doesn't necessarily go round it in spherical space like this other one was doing. So if I undo it here, this is the other one. Now it goes round it entirely, always going up. So yeah, it just depends on what you're trying to make. Sixteen scale on the pole, and it's on the correct axis. It should look good. Oh, did I? Right, okay. But yeah, that's just the other way of doing it. Yeah, it's just the problem is, oh, yeah. Yeah, maybe, let's give it a go. But I did it both in Cartesian space. That's the wrong axes. See how it looks here like that. Yeah, that could do it. Yeah, it probably looks better on it. Yeah, I've got to obviously make it look more like wood by tweaking colors and scales of things, but it's possible right now with this. That's cool. Right, so the other one I wanted to make. So let's save this one and let's go to another submaterial. So we're going to go to another submaterial and we're going to try out the other feature that I want to support, and that is layering actual. So I think this is the final feature I want to add. We'll double check though. So imagine if, so this is all about blending the result of the noise values. What happens if you take a noise value, color it, and then do another noise value, color that. And there's a way to sort of blend these things. Now I was thinking, why don't we just take the Voronoi noise and we'll do it in Cartesian space. And yeah. Yes. And what we'll produce, let's get rid of all this stuff here. Might bring some of it back. Let's just start basic again. Just need 3 instructions. All right. So we give that a run. What we'll get is just a basic Voronoi noise across the surface here. Now we probably want to use another scale. Now what I want to do is imagine each of these sort of Voronoi things as windows into a texture which is behind the scenes. Now what we can do then is take them. So there's a mask, right? And so we'll make another texture. We'll give it completely different colors and everything. Maybe we'll just take some of the, I don't know, we'll see. So we can imagine these as like windows into something behind. And there's a mask value, and that's saying how much I should take that texture over the other one, right? Yeah, do we want like a duplicate instruction as well? And then you can smooth step the result, isn't it? So we could say dupe the Voronoi noise, then smooth step. That'd be another cool one. Yeah, so I want a duplicate instruction. That'll be fun. So with dupe, all it does is take the value off the top of the stack and put it back on there again. I'm going to take the value off the top of the stack, just plonk it on there again, jobs again. Nice. So what we can then do, this allows us to duplicate the Vroni noise, and then it allows us to add a smooth step to it, and basically push on. So we'll say the Vroni noise from 0. Where's the boundary, right? There's a final boundary here. It's from 0.35 onwards. It goes to this color here, I think. It's this color. So we take that, 0.35 to 1. Well, maybe we'll take it to 0.4. Something like that. So it's got nice smoothness where it lerps it. And yes, that's the mask, right? And then yeah, so I think why don't we add another Vroni noise underneath? And this Vroni noise might be like sort of stretched out along one of the axes. Let's just super stretch it so just it looks a bit bananas. And then that, you know, I guess let's do it in spherical coordinates as well, right? And I guess we'll put, I've got to do another push, isn't it? We need to push an immediate on to for the blend mask, which we'll just push on 1. Push immediate. Right, Vroni, push on another Vroni. Sorry, I want to color it. So this time we want to color that one based on a completely different set of colors. Now, why don't we... Well, you know what? Why don't I just take the volcano one we did earlier? I don't need to do that crazy scale, do I? That sort of volcano one I did earlier. Why don't we take this? And then with that... Yeah. So with this one, maybe we'll change the scale a bit. We'll make it more high frequency. And push on that immediate, color it in, right, and then we go again. We'll do another Vroni noise, and it'll be this looking one basically. We'll duplicate the noise result, and then smooth step it, and this will be our mask to blend it in with the one that's behind it, which has already been colored in. And then finally we'll color, and it'll take the mask and then it'll blend it. Now we haven't got the blending code written in yet. I don't know, we got to do like blend modes and things, so we will actually implement it. So let me just get it compiling and working. So we should see probably nothing change. Right, that was the hope. Nothing changing, but clearly something got messed up. Oh. The dupe instruction wasn't in the right place. There we go. Okay, so nothing technically changed. So this is where the fun begins. Now, in this color grad instruction, which basically just takes a bunch of different sort of edges where colors get interpolated between for albedo, emissive, metalness, and roughness, and the input value is the height, which is emitted from some of the noise stuff before or the previous instructions that have manipulated those values. So we take the height, we take the mask, and we basically just evaluate the gradient based on the height, and then at the moment we just store it in the albedo. Now we've got to figure out how we blend based on the mask. So the first way we could do it is you just do a typical alpha thing. So maybe we just do blend modes. I just have different blend modes. I was reading about the ways people deal with the pole pinching problem, and apparently it's common to use textured patch in the way you made the blend thing. Oh, interesting. Right. Okay, that's good. So I'm glad we did something that people already thought about in the past. Right, triplanar. Yeah. Yeah, I basically get around the pole problem by using just the normal one usually, but since we did it for, it produces nicer textures in some ways. Because you can get something going up in the same direction all the way around the sphere. Wow, doesn't that look lovely? Look at that. Oh, obviously it looks a bit fake, right? But artistically it looks amazing. I'm not sure about this sort of blending, right? This is this trying to be like a atmospheric scatter? I'm not sure about that blend, but that's pretty cool. You know, it's interesting how much like if I wanted, you know, there's this sort of like thing where you could basically script out a whole movie, right? Design the whole movie on like pen and paper and basically just go and implement the whole movie in shader code and produce, you know, probably quite a cool movie just by botching a bunch of maths and writing a bunch of shader code and making some scenes. I wonder, I think when you get to sort of characters, it might be a bit. Maybe it's still possible, right? You see, IQ do it with his. He makes some characters in sign distance fields. But yeah, when it comes to like planets and things, definitely easy. You can make lots of cool stuff. Scroll down to the polar part. Right, polar patch. Right. Right, pinches. Interesting. Yeah, that seam as well. Yeah, so I have the seam because I'm generating a noise, and I'm not. It's not continuous across the seam. And the end of the problem is poles. Oh, there's actually a formula in here. That's the right pitch. Right. Okay, so there's an actual patch that goes over it. It's just another texture or something. Oh, wow. Still don't really understand it. But I see it, what it's doing. It's in some way. I guess it's applying reapplying one of the sides or something. Makes an almost fractal coordinate space at the poles. Oh, right. I see it here. Right. Oh, I see. Oh, wow. Pretty cool. I didn't realize such thing existed. So it's just doing it like just with that. Oh, for crying out shit, a toy. Right, it's a little bit more. But yeah, that's if using spherical coordinates though. Like you can just use a different mapping, but okay. That's cool though. Uh, Right, I don't think I need this anymore. I happen to be tweaking out the atmospheric scatter shader in the background of the stream. The funniest came up, yeah. Nice. I've not actually done any of that stuff. I've not actually looked into how that works. But yeah, looks cool though. Right, so we're trying to do the blending now. So we've got this mask, and we've got a previous values that store albedo, emissive, and emissive strength. So I'm thinking like we could just do a standard alpha blend, but with just one alpha value rather than two alpha values, right? Yeah, I think let's just start there. If we need anything else, we can always add it on top and preserve backwards compatibility anyway, right? So I think the way we're looking at doing it is probably just with a lerp. Wait, are we doing a lerp? I think so. So it'll be lerp with an S. Albedo dot RGB. That value there. And mask. I think this is all we're looking at. Be pretty cool. Alright, so emissive strength. Now that is just a lerp. Float 32. Metalness as well. So lerp float 32. Metalness, roughness. Yeah, I think that's it. So we hit the recompile, hopefully it doesn't crash. We should get a nice window into the texture behind. This should go. Right. We obviously got a crash. No biggie though. Let's get that music back. Oh, I closed the music whilst also saying I won't be needing this anymore. Okay, brackets. Not got the mask here. Okay, so the windowing didn't really work. It's I've done it the other way around. So it's keeping the windows rather than not keeping the windows. I'm calling them windows, but yeah, they're the things that should allow us to peek through. So I think I need to invert the mask the other way around because I'm saying, or do I? So 1 is supposed to keep, 0 is supposed to discard. Yeah. So I think that's fine. Let's look at my instructions. So you do the running noise, duplicate it, and to produce a mask, operate on that mask, smooth step it such that it returns a 0 value if it's less than or equal to 35, and then 1 if it's 4, and then anything in between that would be between 0 and 1. Then we do the color, which should be this. So that seems alright to me. What is that look? What is that mask doing then? Yeah, it's gonna be fast actually. Yeah. I was thinking I haven't done this for a while, but actually after I've done this material editor for this, I should get my wife on the stream. I haven't asked her yet. And then do a stream where she just sort of, because she's not really done art. We'll see how easily that she can make a good looking material with this. And then that'll be a good test. So it should be pretty easy to pick up and be able to make stuff pretty fast with it and serialize it out, save it, and then it will just be able to tweak it later on. Does she have a technical background? Well, she knows how to use a computer. She's not like bad at it either. She uses she works at a hospital, so she uses like hospital equipment. But yeah, she's not like super technically literate though, but she's not like a geek, but she's pretty good on a computer. If you will. As a standard user, I would say. Oh. So let's just put a mask of 1 in and just see what we get. Yeah, we get that. That's what we expect, right? Then we put a mask of 0 and we get the volcano. Oh, we shouldn't get the volcano because it will just, yeah. So we did, okay. So apparently this mask value is not what it's supposed to be. So we duplicate, take, put on value, yep. Dupe, definitely coloring it, smooth step. Let's tweak the immediate around. 0, then 1. Oh, okay, I'm being a dummy, that's why. I meant to inverse my smooth step. So, what I want it to be is actually 1. Yeah, so... Right, so I got a sub instruction, but I haven't got an instruction which allows me to do one take. So I need a way to say. So the problem with the sub. Oh no, I have add immediate, isn't it? But what I want to be able to do is immediate. Yes, add allows me to do sub. Right, mul allows me to do div. But yeah, I think what I want to do is to take these and then allow me to do basically. Wait, do I need to be able to do a. Yeah, let's do these. But then immediate adds, just the other way around, isn't it? Yeah, so I needed one more instruction. We're going to see how someone who's never worked with noise before builds an intuitive model in their head about how it works and the maths behind it. The human mind is insane, mind blown how humans can figure that stuff out. Yeah, so I think in the UI I'm going to have some way of visualizing this stack in a sense and say, because here's the thing, right? I'm sort of building up this mental model of like what's going on here, and I'm still getting it wrong because I can't visually see the data. So what we're going to need to do is be able to sort of click on one of these operations and just say, let me see what that value is. And so what that will probably do is insert another operation, which will be basically a color grad, and it'll just input out as basically just color from 0 to 1. And then it'll just visualize it on the sphere. And I'll probably have texture views as well, because I've got the texture viewer. Right, so I've already done this sort of code before. Like able to view textures live and stuff like this. So all I need to be able to do is basically like take some of this code and make it work in this editor where we can visualize the texture in a sort of probably the octahedral map layout maybe as well to visualize it there. We'll see what's useful. So I want to do immediate add, and then I want to do, so the immediate would be, oh, but I can't, I want to do immediate sub. Crap. Yeah, mul is cumulative, isn't it? Yeah, so you do it either way, it doesn't matter. I should probably add just sub and div. Yes, the problem is I can't, well, I can negate the other value basically. Yeah, okay, I need more instructions. Damn it. Maybe I'll add immediate sub and div. That's what we'll do. So that'll be one take. Yeah, so let's go and get rid of the add one. We'll put div in there as well. Because they can get the sub the other way around, but still a minus. I'm gonna divide like that. Alright, this is what I wanted. Doesn't really look that great, but this is just what I wanted to do. We can tweak it around. So let's make it start from 0.3. So we're getting two different layers of materials that get blended together. So we're going to make that a bit of a wider blend, let's say. And let's increase the frequency of this background Veroni noise. It's probably 5. So this just shows we can do layered materials that then get compiled out to a single material in a texture. And so you'll be able to do some crazy stuff like this. Cool. So that's super flexible. I think I want to play around with the domain warping, and then I think I'm finished. But yeah, so we've got these sort of like windows into the texture behind. Yeah, same for add, yeah, that's right. Yep. So that's cool, so that's another one I guess we can just keep there. So I guess we'll do another one. We'll go back to playing around again. I want to play around with the domain warping again, because I just want to make sure it's fine, because here's the thing, it's like this shader can only be added to after I'm finished with it. So I want to just double check one aspect of it, because that's the thing where yeah, because if we basically edit some of the code, it will break all of the materials which have already been made with it. They will just not look exactly the same as they did before. So there's that. But yeah. All right. So something I haven't tried doing is like stretching the it into an ellipsoid and see how that looks. But I can imagine how it'll look. It's taking a normal one. Emissive. There we go. Cool. Let's do the domain warping, and then we'll I guess we'll look at the to-do list for the next couple of streams and edit that. Because I've got some ideas in my head that I want to toy around with before we go and do them. Rightio. So we're gonna up that to submaterial 3, and we'll take the old volcano. Volcanic ground. That's what I meant to say. All right. So we're gonna look at the domain warping again. I'm just gonna take a quick break, get a drink, and then yeah, we'll look at some domain warping. Right. BRB. Alright, welcome back everybody. Oh, let me just close my door. Yeah, there we go. Alright, so we're going to do some domain warping now. So that's something we've already implemented. I just want to just double check it. So those who aren't familiar with domain warping, it's basically you're doing a fractal Brownian motion again and again and again, like recursively, and every time you sort of get one back, you're modifying your sample position. So the fractal Brownian motion is basically just doing your noise function, like this Ronnie noise or a simplex noise, but doing it over and over and over again, and sort of blending higher frequency versions of the noise in. So I can show an example of simplex noise. There's a shaded toy with simplex noise, and it shows his simplex noise by itself, and here's when you sort of do fractal Brownian motion on it. So essentially it's getting smaller and smaller versions of this and blending them in, and as it gets smaller and smaller, less of it contributes to the overall result. It entirely depends on the settings you do and how you do it, but yeah. And then all this sort of thing here, this domain warping, all that is doing is doing a kind of a fractal version of fractal Brownian motion in a sense, but on the sample point, but applying it to the sample point. So it's pretty insane. Oh yeah, and as I went down to get my drink, I spoke speaking with my wife, and I was saying how well this thing was going, and I said after we got I was saying to her if she would like to come on and do a stream where she tries this out and makes some material, and she said she'd be interested in doing that. That'd be cool. So once I have my whole easy to use in-game system, I think that'll be in like a month's time, maybe. I'm hoping I'll have it by April. I think she'll come on, she'll try and use it, and she'll make some textures. I think it'll be fun. See how easy she'll use it. Hey, Matthew. Interesting. Matthew. Let's see what you did there. Hey there, I've been looking around here for quite some time. Quite impressive work, as I understand it. Your engine only renders ellipsoids, yes. Is your goal to build them in more complex shapes, models out of ellipsoids? Yeah, it's the basic idea. I've not done that yet, because I haven't really got an easy way to do it other than putting some points in to an array and rendering it. But that's kind of long. So the idea is after the material editor is done, I'll go and make a model editor. And then when I have the model editor, I'll then be able to make some test models and stuff. And yeah, so it is definitely a bunch of R&D in a sense of I don't really know what will look good. And it's a case of just seeing how it goes. But I'm definitely not going to do LODs because there will be pop-in. In the past, I've done a bunch of R&D on this stuff, and I've tried to do LODs, and if you do LODs, you basically have to sort of either blend between two levels of detail, or you have to take all of the spheres. The object as a whole has to be what's the way of saying it? When you're switching at LODs, the surface normal has to always be pointing the same way, which is impossible if you break a sphere up into many smaller spheres. So you basically have to either when it gets really small, you have to make it always basically one normal for the whole object, or in general, each sphere just points the same way, which is not really the rendering style I want to go for, I think. So yeah, I think what we're going to probably do is have this sort of top-down game. That's what I got the idea doing at the moment. So we don't really need to have a full LOD system. So we should be able to make some like funky stuff just with that, I reckon, and build like some models out of ellipsoids. And it's just a case of like, you know, these things just shouldn't get too small, and the detail on them, like, this could be too big for a sphere depending on how big it is, like the detail on the sphere. Yeah, it's just a bunch of like playing around with that basically. So I might, after I got the tooling in, see if I can sort of put something out that people can download and just play with, and just see what people come up with. That's where I probably wanted to get to in like a year's time. And see if there's someone who just is interested in making stuff with it. Like, I don't think I want to do the art. It's something I can do if I put time into it, but there's so much programming to do that I probably just want to stick to the programming, so I need to probably find someone who will be interested in doing something weird with the tools that we have made, basically. But yeah, just ellipsoids at the moment. I don't think there's going to be any. We might have other ways of rendering some other effects, but in terms of geometry, it's probably all going to be with ellipsoids. So I want to try the domain warping. We just added this. So the thing is, though, is this is just some sort of loose maths expression. It's not really. I think maybe this is true for like one-dimensional, or it could be true. But when like IQ tries to sort of implement it here, I think this is just a way of simplifying. So yeah, this is it. This is it without the domain warping. This is it with domain warping, right? It's just doing an FBM, offsetting the point and doing it again. And then this is it doing it a few times. Now, when he actually does it though, he ends up like doing something a little bit different to what is in that maths expression here. So we're doing it inside of a for loop, so we're not really getting the flexibility of defining a function for it like this. And when you define a function for it like this, you're already getting a sort of a very fixed. It's kind of fixed. I want to try and provide a way where some values can get passed into sort of scale and offset in a sense. What's going on? You have PBR renderer, right? Yes. So this is currently PBR. Very basic though. So it's the sort of basic version of PBR, right? It's not got any of the sort of latest stuff stuff that people do. It's just got metalness and roughness, and then I think I do the Orania diffuse model. So it's the little bit more expensive one. I could probably switch back to the other one, whatever it's called. And I've just done a Trowbridge writes GGX. I think that's how you pronounce it all. So I've just implemented that basically. I've just got one light coming down, and then there's another light somewhere, I think, but that's like a point light. Wait. Spotlight. No. It's a directional light. Yeah, so I've just got a couple of lights basically, and they just come down in a single direction. I've still got to do lighting and shadows and stuff like that. And GI probably. So yeah, I haven't touched any of that just yet. I want to get the scene first before I do any of that. Yeah, it's not going to produce like the best sort of realistic graphics or anything like this. This is just going to produce some sort of kind of weird, different, and hopefully unique-ish looking game. I'm not really planning on trying to make something which is like realistic. So the materials that get made in this material editor, I think, we're going to use a more sort of stylized renderer. I want to really go in for realism, even though you could probably produce kind of realistic looking stuff with it. Right, so I've got these in the FBM. I decided to put the domain warp in here, and I've just called it domain warp octaves. Probably not the right word, but yeah. And I just add another for loop in, and there's a thing called a domain warp offset, and it just allows us to offset the 8 dots. Let's just do that. Let's up the octaves. So it allows us to, should I have done the Veroni? We should go back to doing grayscale. Okay, it just crashed. No biggie. Should have been 3D, isn't it? That's why. Whoopsie. But yeah, so let's just make it grayscale. So we'll do edge 0 and 1. Oh, hang on a minute. Yeah, just do 0. 2 edges overlap in between based on the value, and then we get same for emissive, I guess. And metalness. Emissive strength. Zero, zero. 1 edge. Metalness, roughness. I guess we'll add make it a little bit rough. Alright. So let's get that back up. Let's monkey around with this sort of domain warp again. Alright. Okay, so that's right. That roughness is really apparent what's going on here. Let's just put a roughness of all on. Just so, yeah, and then we do actually want 2 colors. Thought I had 2 colors going on, but I deleted the line, obviously. Okay. Why am I seeing emissive? Why am I seeing like a red is the question. Oh. Because I only had the red channel on or something like that with 0 alpha. Anyway. Okay, there we go. So, right, do I want to do the Veroni noise? Right, so if we didn't do the domain warp, and we just did it like this, I think I want to bring let's bring the edge down so it gets whiter quicker. I think it's about 0.7. There we go, that'll look a bit better. Let's do domain warping. So sort of, there we go. Yeah, so you get some real like funky looking stuff. Kind of cartoony. So as I increase the octaves or whatever, it's just going to get more and more crazy. So it's going to do another FBM and offset the noise. So we go into the actual functions. So FBM for Ronnie. So here's how the code goes. It's just in a standard FBM right there, where it's sampling the Ronnie noise by multiplying the point with some frequency and scaling the final result with some amplitude and accumulating a value, and then changing the frequency and amplitude based on the gain and the lacunarity, and doing only so many octaves of that. So this is just standard fractal Brownian motion, and usually you just return a value after that. But I added another for loop here to do sort of domain warping in such a way that we could probably just do it with a for loop rather than recursion. So I just want to double check that. So the way that IQ does it here is that it takes that sort of sample point, and then he's sort of just offsetting it a bit this time, and it's not offsetting here, then it's doing it in a different way here, the sample point, and doing two different Fractal Brownian motions, right? And then storing this result in a sort of this vector called Q in Y and X, right? So this is scalar value, right? And then when he does it another time, he's taking that as input. So this is already... So you can imagine this as the first recursion, layer of recursion, I guess you would say, the first one. It hasn't even recursed in yet. And then after that, when it comes up the stack, if you will, it's doing another one, where it's taking that vector as input, doing some different offsets. It's times by 4 as well. So maybe we could have done a scale on offset. Might have been interesting. And then he's done different offsets, and then yeah. So maybe what I need is probably just a scale parameter, and then he's done two different FBMs, one for each axis though, which I haven't done. And then his final layer is just taking R and just applying it without any offset and just returning that, yeah. That's interesting. So I'm not really doing it on a per axis basis. I'm just doing it on a single axis where I'm got this sort of predefined DW offset, and I'm multiplying it by some value. Now I did used to offset the DW, the domain warp offset, every iteration. Maybe we'll go back to doing that. And then I've got this sort of original point. And there's got this original point plus sort of this other point here that he's done, which is interesting. Yeah, so I wonder if we could... Yeah, so this is essentially like recursion, but just done in line. So we're doing it in like a for loop. So we do probably want some scale parameter. And if we just did... Oh no, we're already scaling it here. It's not really yeah, we're already just scaling the value. And then in the original point. See, his sort of... So an interesting thing is maybe like... What happens if we add a point and then the original point does that? Oh, it is, I guess even crazier. Let's get back to the... Oh. So I want to go back to here, the domain octaves. So I bring that down to 2. Yeah, I think we want ways to like... Let's put this down to 1. Interesting, so I could put that to like... That's 14, say. Put that to 8. Yeah, you already do see some of the stretching going on. In your research of fractal noise, have you discovered, thought about, or seen stuff around emergent behavior? What is your outcome you're looking for? What is what do you mean by emergent? Emergent behavior. Is there, if you redefine that for me, please? What outcome I'm looking for? I'm just trying to see, like, in this current thing that we're doing, I'm just trying to see, like, when I'm doing domain warping, can I expose a bunch of different parameters to just get stuff that looks good, basically. That's the basics. Does it look good? So, yeah, we'll do that. Then we had 8 before, wasn't it? Yeah, so I wonder if we have stretch it along a certain axes, you would get these clear things. So yeah, so I think when IQ does it, he never scales along an axis, he always offsets. So what we should probably have is a DW scale that just happens every single time. And then we'll actually use offset for offsetting, right? So let's just put his magical 4 in there. And right, so Veroni we're on, isn't it? It's the one we're monkeying around with. So add that value, but first you want to scale value and then offset. So it'd be multiplied by f dot dw scale. Right, let's give that a go. Right, we're still getting those sort of dark areas, I guess, but well, that's just the Veroni pattern, maybe. That's very Veroni-esque. Let's go back to your. Let's turn the octaves down a sec. So about 8, see how it changes. Interesting. Yeah, I'm wondering where these sort of like dark patches are coming from though. It seems like it's coming from when I have a sort of a non-uniform offset in a sense maybe. And then I think I want to change the offset every single... Oh no, it's still there. It's probably coming from the Veroni noise then. But it might not matter depending on how it's shaded. Okay, so he also like accumulated the original point in there as well. Let's try that one out again. Right, so you can get some like real funky stuff. Alright. Right, emergent behavior new comes outcomes that stems from combination of simpler mechanics, right? Like atoms create emergent behavior by interacting when they become molecules. Right, emergency is the concept of physiological physo sorry. It's the concept of physiolog can't even say the word at the moment. Systems theory science. Yeah, yeah. I understand what you mean. So you have like a system and interacts with another system, and it right forms a set of systems form another higher order behavior. Right. So haven't seen any emergent behavior, right, from doing fractal noise. So yeah, it's interesting, right? Just effectively, like when I did this, 2 seconds, just heard a noise. Be right back. Right, I'm back. Yeah, there's my wife. She just slipped down the stairs. She's okay though, but oh, it's just so scary. I don't like when people hurt themselves, right? Oh, but she's good. She's fine. I just helped her carry the stuff up the stairs she wanted to carry up. Oh, anyway, yeah, so the emergent behavior. Yeah, so with the system that we're building now, is that I was looking at I'm building a way to make materials purely in shader code, and building a system where if I want to make a specific material for a object, what we can do is just create a new custom material, like procedural material or something like that, and write custom shader code to make a whole material. And then I was looking at fractal noise, and I was just seeing all the possibilities with it. How you can make a sort of like lava looking texture, or you can make like rocks, or you can make like stone and marble and wood, all sorts of stuff from just noise. So yeah, I'm basically just making I've basically just made a virtual machine which takes in a set of instructions, and it's a stack-based VM inside the shader code, which will just operate on. It can emit a noise value and operate on that noise value, then eventually shade it in by converting that height, as we call it, into a color for each of the albedo, emissive, or PBR channels, right? And that is what I would say is emergent. What has been emergent about it is it's just you can create a lot of stuff from just noise. So we're just leaning all in on the noise basically, and having it as a foundation for that first shader where we can have a bunch of sliders exposed, and it's just going to basically be a fractal noise VM to make quite a lot of different materials from a single shader. And then anything else that needs to be more specific can just be made on top. Yeah. No, it's like setting up a fractal system. There's a high range. It's like setting up a fractal system that has a high range of correctness and give the desired results for different things. Yeah, exactly. Yep. So yeah, it's gonna be pretty powerful. I'll be able to make probably, I'm not sure if I gave a number, but I could probably say at least half of the materials for the game could probably, okay. 80% of the materials for the game could probably be prototyped in this single shader, and then they might need to be specialized into other shaders to sort of get exactly what the person wants. But in general, it could probably produce like at least half of the materials for the game, I reckon, just with this one shader. So it'd be cool. Save a lot of time. In theory, depending on how many sliders, I can see how some extreme values alone could introduce completely different outputs and other combinations. Yeah, it's true. Yeah, especially when you get it's fractal, right? Yeah, and especially when you do domain warping, when it's extremely fractal. So I reckon we can also change the offset as well. Maybe I think what I used to do was just that's on the simplex. I'm not doing that at the moment. Just do a YZW swizzle to sort of just rotate it basically. And that will mean each point. Yeah, it's cumulative, isn't it? Yeah, it gets pretty nuts if you did 3 or more. I think it just gets so high frequency, it's kind of nuts. So, yeah, I don't know if I like that addition that we did to it where we accumulate the point. It should always be from the base point maybe, but then when you do that, you have problems of just getting more and more defined. Maybe, yeah, it's probably okay. Right, so I think this is fine. Let's try the simplex noise out. Let's make the additions over here. We just did that. So it was simplex. Now simplex works a bit differently. I need a bit more gain. Probably need more lacunarity, I think. I didn't even try more octaves on the FBM side of things. Right, that's because my color edges stop at 0.5. There we go. See, we're getting this sort of... maybe not. I wonder if we're getting that sort of black edge from... Yeah, that's pretty funky. Probably make some sort of like watery looking things with this, maybe. I don't know. Change the scale. We're interested if the output could be a bunch of screenshots of different adjustment. If you could output. Yeah, well, there will be, like basically when someone makes a material, all the options will be saved out anyway. So you'll be able to search for all of the, just basically, I have a bunch of like already made material, like the more materials that get added, the more examples there will be, and that will just be it. So yeah, it'll be pretty powerful that way. Let's add more octaves there. Right, it's too many octaves. Oh. Yeah, reduce the scale maybe. But yeah, I think it's alright, does the job. Like, my concern is though, like, I wonder if you can get something really different if... Yeah, I wonder if these really... Alright. Yeah, I wonder how much of this actually changes things. The scale definitely changes. Uh. Yeah. Try 1.4 on the gain. Might get more defined now, isn't it? Ah, no, I just lost it. But yeah, I'm not sure if that's main warping, to be honest. I think I'll just leave it. I don't know. Yeah. Don't know about it, to be honest. Right. Okay, I think that's it now. I want to move on to probably just thinking about the rest of the... I think this is a good place. Let's just commit this code and look at what I want to do next, where we're at, basically, for this material work. I wonder what happens if negative values or just goes off the deep end. Yeah. I don't think it's programmed for negative values. Okay. So I think we're in a good place here. You know, we made this sort of volcano one. I guess I can just quickly show through different ones I've done. So we've got sort of a volcanic ground looking one, which has a bit of emissive on it as well. Yeah, so this one, we have... Was this the wooden one? Yeah, this is the quote-unquote wood, where I've just sort of blended in two of them. I've just blended two of the noises together with the virtual machine thing. This is using spherical coordinates, this one, because it goes round, and this one's just, yeah, the other way. Then this one is the... where I'm showing you can do layered materials. But obviously it just emits one material at the end, but whilst in this virtual machine you can take one set of noise, color it, and then you can take another set of noise, color it with a mask, and that will blend it with the one that's already there. So you can sort of peek through and see the layer underneath it. So that's pretty powerful as well. Yeah, you can do tons of good stuff with that. Like, we can add like scratch marks on stuff, basically. We can get a nice scratchy, like, part, you know, we can make like scratched metal, like, quite easily. Should be quite cool. No, worn out, you know, tons of good stuff. Wait, should we try making a scratch metal one? Won't be too hard, will it? Yeah, fun potential, yeah. So, where we did the two, it was this one with the Veroni. No one. It was this one. Yeah. So to take all these, I reckon we can achieve like a scratched metal. Pretty bananas. Let's see if we can do it. And then we'll get to the list of things to do. So I reckon, right? Because we haven't done metal yet. So let's just say let's do a basic shade, but we're not going to be doing red, yellow. Instead, we'll just do two edges. Going from zero to that one. Something like that. We'll see how it looks. And then same thing here. But this time we'll add a bit of metallic. So no emissive. And metalness 1 all around. And roughness, let's say it's not very rough. So it's going to be a perfect mirror. And then we can put the scratch layer in. I'll vote one more. Are you going to have these references saved in unique configs with different slider values, or save the files with their basic changes as starter materials? Oh no. So effectively there's going to be like, so there's a shader is called, like, I think I'm calling it a proto material, and that just exposes a bunch of options, right? And there'll be an editor for each shader that someone makes. I think I'll try and automate an editor with reflection. But if it's a little bit more complicated like this one, you can do a custom editor as well. Then for that proto material, you basically can have a bunch of saved materials, which are effectively all of the inputs for that proto material, all the different sliders and stuff like that, saved out as just a bunch of like a configuration. And yeah, those would just be stuff that people can sort of copy paste and yeah, stem from there, or just look at basically. Well, hopefully it should be intuitive enough to sort of, the editor should be intuitive enough to use, so people should just be able to pick up and get going with it. Like, it's just putting noise down and just seeing what looks good and adding color to it. Stretching it along a dimension, see how it looks, doing spherical coordinates, stuff like that. A bit of a play. Let your imagination go wild. So this is rock with a bit of metal in the middle. Reflective metal. So what I would like to do is get rid of that. Right, so Voronoi noise, I'm just trying to make color in metal, right? Then I do another Voronoi noise. Now this is where I want to change out for a bit of simplex. And then I want to say, right, it's probably like heavily stretched along a dimension. I don't know. Give it a go. And then let's get some music going. And then heavily stretched along a dimension. And then let's add some octaves to it. Go to about 1.05 for linearity. Yep. Now, after you got that, that's our scratch surface, if you will. So how much of this we're going to blend is that we need a blend mask. So for now, let's just get that sort of scratched surface showing at all times. So I'm just going to basically push an immediate in there of 1. And that's our mask. So it's just going to say keep the latest noise when I do the color grad. So let's get rid of these for a second. And let's just see what the scratched surface looks like. Shoot. So we got 5, is that right? No, 6. Cool. Right, so if I color this in, so all I'm really interested in color-wise, see, that's the thing as well, it's like, if I'm adding this sort of scratched layer on, I don't really want albedo or emissive or metalnet. Sorry. Yeah, I just want a roughness layer. What I want is a roughness layer applied on top. I don't want a yeah, so perhaps we need a way to say like I don't want this channel enabled, maybe. Yeah, you keep it. Oh, you can keep adding more operations. Yeah, you can keep adding more and more. It will keep going. This is a stack-based VM. So, and then there's a color. There's a color on the stack. There's a color on the side. And whenever you do this color grad, it sort of just adds to the color, and the color is what's put in the texture at the end. So you can keep putting noises down and coloring them in, basically. And they just keep blending. So I need a way to say like, so with this color grad instruction, we need a way to say, you know, I only want, so I guess you could say color space. Could you say color space none? I could say color edges 0. And if it's got 0 color edges, it doesn't do anything. I don't know. What would be the ideal? So you have no color edges. Yeah, let's just say 0 color edges does nothing. But then when I do the code, what do? I need to say if I guess that's the way I'll do it. So like, if you put no color edges on, then it will not bother doing the lerp. I think that'll be ideal. Yeah, so go to emissive, strength, metalness, roughness, and this way I don't have to change any of the previous ones. It should just work. So now we go back to, I was about to say here, but it didn't go back to where I wanted to go to. So we go to such a simplex. All right. So I'm adding, right, so if we put 0 color edges for albedo, 0 color edges for emissive, 0 color edges for emissive strength. And I just want to change the roughness and add these scratch layers. But, oh my days. Yeah, we won't be able to see, oh. Yeah, let's just put it on. So roughness is going to have, and also if you want to visualize this without, okay, RGB. All right, here we go. So you need a couple edges. So let's just say it has a sort of a linear, from 0 to 1. So edge 0 is off, edge 1 it's all on, right? So we run that. We should just get a scratch layer go on top of this sort of metallic texture. There we go. So the problem is we've got this sort of black and dark green, but we're seeing it, right? It's got a stretched, it's a stretched simplex noise along a dimension. Yeah, it's looking pretty cool. We're getting the metallic reflection, but where it's rough, you're not really seeing it reflect that well. And obviously when it zooms out, it's like different MIP levels, so it will average, but... Yeah, I think it's fine. No, this green is fine. This comes from the Voronoi noise. Like, if I were to say, instead of the simplex, push on an immediate of 0 instead of the Voronoi. Crying out loud. Yeah, so let's just try that. So I've just... Yes, this is what it... Oh crap. Sorry, instead of the simplex layer. Why did it... Oh, because there's a perfect mirror. And if it was reflected... yeah. Yes, this is if it's just got all roughness on. We're seeing the Voronoi noise underneath. Yeah, so... all of the eyes. So yeah, it's just not that bright really underneath. So if we just change the color a bit, we could have put some emissive down at least, but... It's up the... Yeah, let's make this 555 instead, right? There we go. So we're seeing a little bit more popping through. So if we drop the... Let's drop the scale a bit. We'll do want it to be a little bit bigger. And then we'll add the scratch layer on top. Oh, that's not what I wanted. Alright, it's definitely bigger now. So now I'll put the scratch layer on top. Let's get rid of the immediate there and push on the simplex noise, which gets layered in. Yeah, so that's going around. It's going around this way, isn't it? You can see it. So that's just to do the way we stretched it along the axes. But yeah, we can do it across this way instead. It's pretty cool, isn't it? Got like a... It does kind of add a bit of realism to it though, but... Cool though. Do tons of stuff with this stuff. Yeah, full reflection. Let's try that. Let's go back to the reflection code. Sorry, let's go back to having the one that just fully reflected by accident. So that was if we pushed. What we did? Yeah, 0. That's 0 roughness, isn't it? Right, 0 roughness. Yeah, so... I wonder why we don't see... So the albedo... There we go. So that light... See how that light is now tinted to that green color? which was the albedo color of the material, right? Yeah. So yeah, we're not really changing normals either yet. That's something else to look into, is normals. Something to figure out how I'm going to do that. I have not manipulated normals yet with this. That's another thing. We have got a normal map. So I've got a height map. We are up in a height map and a normal, actually. What I'm thinking about doing is, if we just take the height map, we can produce a normal map from the height map, can't we? So maybe there could be another pass for the shader which takes the height and then just does the normal based on that. I think that'd be, then this will look different. It actually will show the grooves. They're baked. It's IBL. It's image-based lighting. So it's just this. So I've got a specular map and a diffuse map. You know, a radiance and a radiance map, basically. That sort of thing. Or pre-fill map, and, you know, that's those sorts of names. So this is just a sRGB texture I've downloaded from the internet. It's a cube map by some guy on the internet. He's got a bunch of them. And yeah, like, I posted something about my profiler on Twitter, and some people were like, wow, that rendering looks sick, it looks so real. And I was just talking about my profiler, and people were just like talking about how real the rendering looks, but it's just a picture that someone took on a camera. That's why it looks real. Yeah, funny. So yeah, sky maps and environment maps stuff, and probably sort out in a good while. In the meantime, icons look amazing, I guess, when people don't know it's just a picture. Yeah, it's good, isn't it? It's just a metallic reflection. Yeah, it's just a reflecting. It just samples into a cube map. In the future, I would like to get. That looks pretty cool. In the future, I would like to get, you know, reflections of the environment as well, maybe. But we'll see. We'll see how useful it actually will be. This sort of game we're going to make anyway. So cool. It's pretty nice. That's another material to add to the list. I'll probably take a screenshot of these. Yes, lovely. Lovely. Tile. Yeah, they are tile. What do you mean by tile? Because it's just on a sphere. Alright, or it'll be on an ellipsoid. So it will be stretched a bit for an ellipsoid. That's the thing. But it'll be fine. What? They do tile because I use an octahedral mapping. So I'm basically, it's kind of like a cube map, but I'm just doing it in octahedral space. So it looks like that. So that's the albedo texture. It's just sort of, if you're familiar with octahedral maps, right? So it's split into like eighths, basically. And each octant of a sphere, so not a quadrant, like a quarter of it, it's an, you know, an eighth of it, gets mapped to this sort of like texture. Octahedral mapping. So stuff like, not this one, that's a hemisphere, but this one. So it's split into eighths like that. And I take the normal of the sphere when I'm trying to shade it, and I just do whatever I want with that. And that normal is also in the local space of the sphere, is also a Cartesian coordinate, right? And then you can just do whatever you want with that. So you don't really get the, you don't really get the rings or the poles basically, unless you convert it to spherical coordinates, which we do still support doing that, but we have that as an option in this shader. Hello, do you need help? I'm a graphics engineer and love making shaders for fun. Awesome. Welcome, fellow graphics engineer. I don't actually need any help though, but thank you. Appreciate it. What sort of stuff do you work on? Give me the details. Sounds really cool. Nice to meet you. I also do 3D graphics as well. I'm a mid I'm a mid graphics engineer. That's my title, mid. But yeah, I've done some stuff. Cool. So, right. So, I guess let's leave this running because ain't that bad. Let's commit what we got though. Git status. Now I've got to go onto Windows tonight and commit the new version of my compiler because there was a slight compiler bug where I couldn't do anonymous structures, so I had to sort of fix that. Because the debug code was the code that emitted the debug type info crashed because it was expecting a name. So I've got to fix that and put the Windows exe in there as well. Now, so I guess we're going to say like finish super general fractal noise material generator VM shader. Yeah, it's completely bonkers. It's a bunch of words you didn't really expect to be put together, but there we go. That's what we've just done. So we'll git tag that with day. What day are we on? 3.2 is it? 3.3. Right, so this is how we lose track of time. And I'll put that up after the stream is done. What? And I guess let me just quickly throw this up as well. Fix anonymous. Not anonymous. Anonymous structures. Yeah, struts. So when I go onto Windows, that'll just be ready to pull down. So I guess I can just exit that. So I want to look at the material plan. This is what we're kind of working on. And I want to sort of think this through before we go back and execute on this plan. Because I've changed some ideas, I think now, since we built this thing. Most recently, I made a portal effect for the Apple Vision Pro with polyspatial without stencils, depth tensing, or render textures, right. Ooh. Huh. Oh, so you just did it in line. You pure mathed it. Nice. Awesome. Yeah, it's nothing better than a bit of pure maths. Yeah, it's always... Yeah, it's just interesting how you can just basically just cheese good effects these days. We're just sort of putting in some like signs and stuff in maths. It's fun. So it's like an art to it. Yeah, it's what we basically did for these. You know, it's good. That's awesome. Are you doing that sort of to your custom shader that, yeah, run per frame, isn't it? So you got to make sure that's not too crazy. Because like the stuff people do on Shader Toy is pretty unoptimized, isn't it? Typically, they just put tons of maths operations in. So you have to be careful what you select if it's real time, especially for VR. I have an alias A that adds in all the next which commits with work in progress. Squash everything to the PR layer. This is the way. Yeah, I'm gonna be doing that maybe on a few things that work on the side. But yeah, when I do stuff here, I just put in a little. Yeah, it's just me working on the project. I try to not use branches because Git is dangerous, and every time I use Git, I could blow up the universe. It was because not a ton of traditional methods were inspired polyspatial. Just a few dot products was nothing crazy, no square roots, for example. Amazing. Beautiful. That's great. Mm. Right, so in the end we settled for octahedral. It just seemed to work out well. We've got these PBR textures. Now I've not really done them in BC compressed yet. That'll just come later. So I have a beta emissive. I was thinking about putting emissive strength as a separate channel. But every time I've sort of played around with emissive, you see, and I've done a different. Let's go back to the shaders, and I've done a different emissive color. So I guess if I did a different emissive color, what was it? Yeah, it just made it such that it looked pixelated or something. So let's try it out, right? Let's move this one. Let's make the, rather than the red being missing, it'll be the green that's being missing. And then we'll, actually maybe we'll make it miss too, and it's only got the red then. It's the inverse kind of. And then let's actually put some emissive on. Let's put half the emissive, and let's see how this shader looks with a different emissive color. Yeah, so we see that it's a very big it's a very different color, and I think that's, you shouldn't do that if you have a different. Needs more glow. Let's make it pop. Hmm. Yeah, just made the whole thing light up, but like, really what should happen is the layer on top should have dampened it with the sort of roughness map, right, in that sense. So roughness map that got applied, we should have actually put a emissive of nothing on those or something like that. Yeah. So we'll say, hey, what am I doing it? Well, I should really monkeyed with the emissive strength. And we'll put it down 0. So now where the scratches are, it shouldn't. There we go. So it's emissive underneath now. So where the scratches are, it's not emissive, but the layer underneath is emissive. And well, I don't even know if it really shows up that much. It'll be a blend between it, that's for sure. Wait, why is it pushing a 1? It's pushing a 1. It's not doing a blend between it, is it? Yeah, it's doing a 1 all over. Yeah, so all over, it's just keeping, so the emissive strength is being completely overwriting this. And so is the, right. Already be a point of blurring and converging or maxing out. Yeah. Yeah, so what's happening is that we're just replacing the emissive here because the mask is just set to 1. Yeah. So it's just set to 1 here. So it just means that, so the simplex noise is here, then this is the mask, and then this takes the 2 values off the stack. And so it's just keeping all of the emissive strength from this one, and the previous color grad would not be contributing at all. So what we need to do here is we could do I did this before. You want to say based on that simplex noise, so you do a dupe. So you duplicate the value on the stack, then you do another instruction, and we can then smooth step. I don't want to smooth step it. Do I care? So that I take that simplex noise. Well, let's just use the simplex noise as the mask. So it'd be between 0 and 1. Yeah, that'd be alright. Okay, so now what we've got is roughness. Where it's rough, where it's very rough, you've got no emissive. And where it's okay, so the layer underneath, the problem is that the emissive is just all on in this case. So what we want to do is probably have 2 edges for it, such that it's only emissive in the bits where we want it. Like probably from about that 3.7 height, you know what I mean? So that'd be 3.7. So 3.5. So no emissive. Yeah, then you probably want 3 edges. You probably want no emissive at all. Yeah. Yeah, 3.5.1. So you'll be like, actually, you only need 2 edges. No mistake. 2 edges. 3.5 and below would be no emissive, and everything above will be 1. Right, so that means that only this sort of blue will light up. Okay. So we're getting that sort of scratchy surface on top now, kind of, but which does dampen out, but it's but yeah, so we are seeing, you know, when it's coming in very fast. So this is where you do that sort of wider area, and then it will sort of blur in basically, and maybe you shouldn't go all the way up to, yeah, it will lerp in basically, and maybe we shouldn't go all on so it's really So even in the dark spots it lights up or whatever, but where is it? 3.5's the yeah, I'm not sure what we're trying to get from this. Trying to see if it can just look good with this emissive, and if we change the emissive color, does it produce any artifacts basically? And if so, should we change the texture format? So here's it glowing on this side, it's kind of glowing in the dark a bit. That looks alright. Not bad. I'm curious why things like this and physics calculations tend to utilize floats instead of just scaling all values up by 1,000. Because you'll get 1,000 might not be enough. So with floats, you get a lot of precision near 0. A lot of your precision is between 0 and 1, basically. But yeah. I'm not sure the reason why. Maybe it's just easier as a programmer to reason about. But there's probably lots of things to do, like instructions, right? Like, so here's what you're saying. You're basically saying like, are you saying like fixed point basically? Not really, because fixed point's a bit different. I'm probably a bit too tired to probably think about it, to be honest. Requires a different headspace for me to think about it. So let's drop that down. Right now I'm in sort of art mode, not in maths mode. Are they much faster on modern CPUs? I thought they were basically the same. Even on GPUs, integer, and they're about the same. Pretty sure that's true. Why would floating point be faster than integer? Yeah. I think that's alright. But anyway, so if I change the color to, let's invert this the other way around. So say 111155, and we have a different emissive color. Now it's shining red. Bwomp, bwomp, bwomp. But the base color is different. It just seems weird if you were to do that. But you know, people, yeah. Yeah, so I don't know if I want to have, you know, I guess you could sort of tint this into a slightly different color. Let's do this other way around. Get like a purple emissive. Does that make any sense? So if we think about emissive for a minute, you're just adding this sort of light radiance, if you will, to the pixel at the end of the light calculate the color. So sorry, when you're calculating the color, you're just adding on this sort of emissive color, obviously multiplied with this strength. So yeah, I don't think really it necessarily makes too much sense having a different color, but I don't. Yeah, let me just give it a quick Google. If anyone has any sort of like, so the problem I'm trying to understand is like, will you have a different emissive color than you would the albedo base color, other than just being a sort of a HDR version of it, a sort of a very bright, version which is greater than 1, say. You wouldn't really, because I wonder what the difference would be. Yeah, so you have the base albedo color, which is what the surface the light will interact with when it hits the surface. And then the color that emits from the surface, because the surface itself is emitting light, even in the dark. Will just be a brighter version of the albedo, basically. But I'm not sure if you'd scale up the albedo. Maybe there's a way to maybe you want to slightly tweak it sometimes, but I wonder how often that would be. I guess we could look at so people have like an emissive map, isn't it? But that's just a whole sort of. Yeah, I wonder if we should have a separate, break it down into 3 channels basically. Emissive and emissive strength, or just have it as one big emissive texture. And Is a mapping you apply at the end where you modify the values are within a specified range threshold? Yeah, exactly. Hey, no idea. How's it going? Welcome. Good to see you. Long time no see. How you do? How you do? No idea. As you can see by the title, I have done something appalling. Wait, what was my title? Is it? Oh, I forgot to put virtual machine in there. I did a virtual machine in shader code. No idea. It's pretty bananas. So basically, I'm writing this sort of material editor, which will probably be done in April. But I'm making these things for like proto materials, where basically you can procedurally make materials with shader code, expose some options that will then get displayed in the editor, and you can tweak all those options and make different materials from a proto material, right? So a proto material is a shader. You can get a material which just has a bunch of options for that proto material, and then it compiles out to a texture. Done. So then I was like, right, let's make my first sort of proto material before I make the editor for it. And then I was just gonna make one for a volcano. Great, so for a volcano, volcanic ground, and then I was like, all right, actually maybe it could be used for rocks as well. And then I was just using like some noise functions. I was like, hang on a minute, you could do basically anything with these things. So then I was like, okay, let's make a stack-based virtual machine, which is about putting a bunch of noises and then shading them in. And so now you can like put on a bunch of different noises, shade them in different colors, and also blend between different noises. So yeah, it's just a stack-based virtual machine. The editor's just going to be what's it going to be? It's just going to be pushing on a bunch of different operations, and you'll be able to visualize what each operation has done, basically. I'm not doing a node graph thing. That's too far. I have my boundaries. Yeah, this is showing off how you can take two layers and blend them together with different colors. And then this one is the sort of metal with the roughness applied on top. Yeah, so it's running on the GPU. So the reason... Okay, so one, I haven't tested performance yet. That will come later when I'm in the editor. In terms of fast, so I've got ways where I can make it fast. Like I know how to optimize it and stuff like that. To reduce my VGPR count and maybe leverage the if I'm using far too many VGPRs, I can probably leverage the group shared memory and stuff like that. But in terms of how fast it's got to run, it's just got to run fast enough where if I change an option in the editor, it is quick. But also, it has to be fast enough because this is going to be used for the build pipeline. So if I were to sort of make a change to the material and then, or whatever really, what would I do? Or if someone was to like get a new copy of the repo and press the run button, it needs to be able to compile all of those materials quickly. And yeah, so that's in terms of like how far that's where we don't have to be like super fast for a real-time game, but it has to still be fast enough such that it's not going to be pain in the butt when building stuff. And I think it's quite alright at the moment. I'm able to hot reload it pretty quick, but most of the time comes from compiling the shaders, to be honest. But that won't be a bottleneck in the build system. But yeah, so I've just essentially got, if I just give you a quick little tour, I got this sort of like this is just, the opcode. You can push on a simplex noise, Ronnie noise. It's just a stack-based virtual machine. So you can push on a random like float value basically. Or you can duplicate the existing one. You can multiply two values on the stack, add with an immediate, that sort of stuff. Negate, min, max, lerp, pow. Smooth step, you can put a dot product with a normal into the stack as well, which has allowed us to do that blending. And then you can color it based on a gradient, and that allows you to layer stuff as well if you keep doing it. So yeah, it's pretty bananas in true Henry fashion. Is the way I roll. But do you want it to have it in game? At the end of the day, no. So the idea is like it's just I want to make it. I want to have like one shader, which is one proto material which maps to a shader that is very general, that can be used to make lots of different materials with, but it won't be able to do something you exactly want probably, but it might be able to go anywhere from 50% of the way there to what you want to 100% of what you want. And you'll be able to do it quick all within the UI. If you want something specialized when you're making something in the game, then you just maybe see what you can produce in this shader and then just basically inline it in, make a new proto material, inline the code, and then tweak to your heart's contents. Add some sliders, add some properties to make stuff configurable at runtime and get exactly what you want. So I think that'll be the workflow. Yeah, it'll be quick. No, it won't. As soon as you have to edit shader, it becomes longer, but it'll be quicker when you're just having to edit values. So I think there'll be a few general shaders, and then there might be some specialized ones. But yeah, I don't want to generate code from it. It's purely build time stuff. I'm not running like the runtime. At runtime, it's just going to sample from the PBR textures, and that's it. Yeah, how's it going with you? No idea. How are you doing, sir? How's life been? It's been a good while. I'm glad people have stopped saying it's been a hot minute, because that was the most dumbest thing I've ever heard. It's been a hot minute. Yeah, Google's UE5 downloads UE5. I'm using this now. So what about emissive? So they have base color, that's albedo, right? What about emissive? Oh, is this not in there sort of like... Huh. Although Grace still struggling with sleep and affects everything. Oh man. Yeah, that sucks, man. I hope you sort out soon. Have you tried just just making it sound easy. Have you tried to I don't know, exercise or something right before bed, just weigh yourself out? Something like that. Kind of get burnt out of work, right? I think that maybe that's not helping, is it? Just sort of, yeah, that's it, burning out of work. Getting stressed. Is there equivalent, is a shader equivalent to a PNG some kind of export? No. Maybe. Yeah, it compiles to this PB file. I'm not sure what you mean exactly what you're saying. Yeah, I'm finding this crap for like 2+ years. Right. Yeah, it seems... Yeah, I guess you can find another place. It's hard, I don't know. Maybe it's hard right now. I haven't really done it, but I'm seeing all these layoffs going on. I assume it's hard. But yeah, maybe if it's stress looking around for another place, isn't it? It's even more stress, right? You're on a job. Hey, I'm looking for another job now, and then it's adding like that just adds far much more. I remember when I was looking for a job when I was basically not working, and the amount of time and effort I put in, it was unbelievable. It felt like a full-time job. And then I remember even buying a house as well. I think you've bought a house very recently, isn't it? You spend so much time on that paperwork. It's insane. It's like another job. I remember coming home after work and just dealing with all that damn paperwork. So they've got a missive here. A fully emissive material. Yes, they've got an emissive color. I don't think they have it as a separate. Yeah, so they. Right. Yeah, so they have the emissive color and then they'll have the emissive strength and they multiply it. Right. And then they'll get that. So, yeah, maybe they serialize it out as a single texture. Anyway, I think we've got our answers. What engines typically do is they'll have just a. They do have a separate emissive color, if you will. So I just wonder if we should separate them. Let's think about that. Let's go back to the dock. Yeah, the house messed me up. Took a month vacation in the winter. That helps a lot. That's great though. Just got that month. Oh, yeah. Right. I'm just gonna take a quick little break. When we come back, we'll go over this plan again and sort out what we want to do for the next couple of streams because I think I want to go back into the renderer and just make a little change before we go ahead and make all of the different, just basically start on the material builder, things that builds these things that we've made into actual material assets. Which be interesting. But yeah. But my body still refuses to sleep properly, can't sleep more than 7 hours. I can't do that either. Wait. I think I can do it if I go to bed early enough. Yeah. But I don't. And I end up getting like 6 hours. Yeah, I think the thing for me is like I can go to bed fine. It's just I can't stay in bed in the early hours of the morning. So if I wake up at 6, I'm up. If I wake up at 7, I'm up. Yeah. It's just my mind is like, boom, programming. So, yeah. Right. I'll be right back. Alright, welcome back everyone. So let's take a look at these sort of like PBR textures. Let's just go through the plan and see what's changed. So I'm thinking like, we've just got the emissive base color essentially. And multiplied by this float thing. Yeah, and we just sample two textures, sample two textures in the shader. Yeah, so I think this, so when we're generating materials, we have them all as separate channels like this. And then when we pack them into textures, like the metalness and roughness get packed into one because then they get sampled together. Right, they'll be stored hopefully better. And then like, the normal will be packed as well into something like this. Now, I'm thinking that maybe we should just always generate, because you can take a height. Yeah, we probably need a way. There's an algorithm you can run, right, to convert a. Basically, you can say so you can take a height map and turn it into a normal map, just like this. So there's the height map texture, and that's the result here. And all you need to do is sample the height map and do this function here. You sample it twice, and three times you get the derivative. That looks at it. There's obviously other ways to do it as well. So you're doing too many computations. This one. Did he change it? Maybe he did. I don't know. But yeah. So effectively we could probably generate a But yeah, so I reckon so that needs to be a second pass which runs after our height has been exported. Now yeah, we probably want to make it that we'll probably just have a function which does this. And shaders can just do whatever they want. So that it needs to run a second pass, isn't it? Changes the normal. Should we try that out now? Yeah, why don't you try that out now? We'll save it for another time. Yeah, we'll save it for another time. So we'll need to write this down though somewhere. We do kind of need it for this shader though. Yeah, let's just do it now. So what's this sort of... There's a height map. Oh, so does it use any UV? And it's in it in line in the shader basically, right? Alright, so we need a function like this basically. Yeah, so we'll need to make a new shader. Let's go to shaders.c. So we'll call it why is it returning a vector 2? Tell me why. That ain't gonna work, is it? No, ours is different. Alright. Well, mine's more different than mine's on a sphere. And it's octahedral map. So what you've got is like you could so if it doesn't change, it just uses the normal, right? If the pixels around it do not change, uses the normal. If not, you need to respect the sort of the gradient of the... So I guess if I draw it, I'll try to draw it. You know, you've got this sort of like, you got this sphere, but technically the sphere is like, if you see the sort of zoomed in portion of here, maybe it goes like this. Your normals obviously want to be following the surface, isn't it? So you got one height here, you got another height here, and so they're the 2 pixels. I don't know, not really good ways, but yeah, they're the 2 pixels. And you can get a vector going like that. In 2D, it would be fine, but it's in 3D. Oh, okay, you can get the other one again, the other dimension as well. And then produce a normal. But then a cross product, which might be it. Yeah, I think you can do it. So you can probably get this sort of like, you have your sphere and on the surface, you got a pixel, right? You get the one above, you get that one, you get the 2 heights. Height. You've implicitly got 2 vectors. Oh, would you do the cross product? So your two vectors which go to 2. Let's see if we can draw it better. So you've got... Oh, you even draw it. Imagine you got this surface like that. 1 pixel's there. You could say this one is directly in front of it, and this one is directly... yeah, well, this one's directly up, this one's directly to the right or something. Let's just say that. You'll have a vector going like that, and you have another vector going like that. Then you take the cross product, and that will give you the surface, you know, the normal, right? Like that. Maybe, if you do the right way around. Or I could give you that way, you've got to be careful. So, if it was more curved, you have one like that, and another pixel there, and another pixel there, let's say. You have 2 vectors like that. Yeah, it's hard to really tell what it'll be like. You take the cross product. Yeah, maybe I'll think about this one off stream. I think you could just do it with the cross products, but I just don't know. I have to have a think about it. And I'll look for some resources probably. No. No, 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 no. That's not what we're looking for. Right. Yeah, I'll think about it. Right. Back to here. So yeah, we'll generate the normal maps separately as well. So that could be another pass that runs in another shader somewhere. Right, so we've settled on the projection to an octahedral map. It just seems to work out well. I've sorted out all the problems with it. There's no issues with it. It's fine. So we're going to have this sort of baked material asset called the .mat file. And then it's generated from a .ed, so short for editor, mat, material. The edmat, if you want to call it that. So it's a bunch of variable length arrays for texture data. And we're just going to be storing literal pixel data in there for now, but we should probably block compress it at some point. It's just doing that block compression now will just be time and effort that we could just do later. I'd much rather get a set of materials and, you know, models and a scene done first before doing any of that. Next thing is, this is how they'll be packed. You have albedo, emissive strength, darkness and roughness into 1 instead of being separate. And the normal will be packed into 2 channels rather than, you know, the third one will be calculated. It'll probably be an octahedral map, or it might be octahedral encoding, or it might be something else. We'll see. Then, so we've got this sort of editor proto material. What does this say? So ed proto material. This is the thing where it maps to a shader. Implicitly linked to SPIR-V file with the same name. Texture list. Yeah, list of textures can have multiple passes that run basically. Well, textures in their format and their dimensions. Do we care about dimensions? Maybe. You probably leave the dimensions out and it becomes the default. Shader passes. Ordered list of shaders that run. Yep, with just barriers in between. List of properties. with the default values, update a property. Yeah, you can just. It's just the behavior of what happens if you add or remove a property, which should be fine. So the editor material is just another CSON file. So CSON is on my C like JSON, that's all it is. It references the proto material. So we've already got one proto material, right? But we haven't just made a file for it yet. Is this fractal noise thing. And then you'll be able to make these ED materials which reference that and just have a bunch of properties. Property value history. So think about storing a history. And the reason why if you store the history, so changes to every property, this means we can undo everything and see how the material changed over time. And then we won't have to worry about going back in version control. And you could, yeah, see what happens when someone made a tweak, basically. We might do that. I think I want stuff to be like that, to be honest. It's nice. Tis the JSON. The CSON. What is... Yes, it is the CSON. This is the way. Hey there, very much. How's it going? Mr. Halsey, thank you so much for the raid, sir. Welcome, raiders. What's up? How's it going? How did the stream go? We're currently revising the plan for materials. The material editor that we're building. We've just built this crazy bananas fractal noise material shader virtual machine. Yeah, that's what we've done. And we've made a bunch of different materials from it already. It sounds like I just said a bunch of words, which I did, but they do, it does make sense. Yeah, so good, quite a big refactoring. Nice. No, I've not got any anisotropy. Okay, any of that. I've not added that to the renderer yet. I'm not sure if I will. But yeah, so that's the volcanic ground one we had. I've got this sort of one which is used spherical coordinates. Why is it running so damn slow? Shouldn't be. Feels slow. Something's going on. Probably because the game's been running for too long and something has messed up in my game. But it blends in another one at the top. This one blends in 2 layers of materials. Shows it off. And the other one was this one. I need to restart my game. Yeah, the comb over. Yeah. Need to run, have a great stream. Thank you so much, Raid. Have a good rest of your evening, I would imagine. And yeah, catch you later. Thank you so much, Halsey. Appreciate it. But yeah, any questions, guys? Feel free to ask away. We're currently just revising the plan. So yeah, we've got that proto material, which is that custom shader that runs. And it can expose a bunch of properties that get exposed into the editor. We then got the material itself, which just has a bunch of property value changes, such that we can view the whole history of that going into version control. And see people's changes over history and see, who changed it and give them the blame. Right, so that's the rundown of the file format. So what we've already done is restructured the project to account for having I got rid of the engine folder. Engines suck, right? Where did you draw the line between the engine and the game? The answer is impossible. So I tried it out for a bit, I got rid of it. I changed it to a code folder, I got an apps folder. I'm going to be putting in the material builder in here. And I got modules now. And they're all my modules for my game, and they can be reused for different applications, like the material builder, for instance, reuses certain parts of the game, right? But not all of it, just parts of it. So that's why we did that. If this is a fractal material, does it mean it has true microfacets? So it could do, but you're storing out to a texture at the end of the day. So the answer would be no. But you're sampling at each pixel as well. But yeah, you could maybe do something crazy, right? Do some super sampling. We added multiple shader packs, as we call them. So you can bring in multiple SPIR-V files and hot reload them. So I was thinking that each proto material just gets put into a SPIR-V file. I generally hate the crap out of this, but it just means that in future, perhaps. Wait. Or I could just chuck it all into a single file. No, yes, the problem is this was it. Your proto material can have multiple passes, and I don't want to declare all of the passes. Is that right? No, but there's the passes here. So we could have a materials file, which is separate. I was thinking, maybe it could be interesting in the future if people want to make mods for the game. They could make their own. Yeah, maybe we'll just have a shader file. I wonder. Yeah, I was thinking if people want to make mods for the game, they could basically just make their own materials and stuff. Or make their own materials for the game, I don't know. Could be a thing. Just having it in one SPIR-V file would be great though. The game. I don't like many files. Do something wild on fractal, sorry, spectral properties of fractal patterns that are smaller than some wavelengths of light. Oh no. Don't. But yeah, how's it been, Reynolds? What have you been up to, my friend? What have you been doing lately? Spiel. Yeah. Spiel the words. Aha, you thought I was saying play in German right there. Been so for 2 days. Oh. Oh, amazing. I'm glad you're back. Just a common cold, I assume. Yeah, so maybe we have a shader file that rather than implicitly link to a shader file, maybe you just go, hey, it's over there. And then if you can't load it, don't work, obviously, right? So, yeah. So we'll still utilize the multiple shaders, but... And then this way, these shader passes will just be names of shaders and they run, yeah. I'm happy with that. And then later on, I can refactor out some of the sort of material stuff into separate files if I want to put mods and stuff, or allow people to modify, add their own materials outside of the game or whatever. But it'd be good to put all material shaders into a single file, maybe. Yeah, because we're going to be making a graphics material builder, and you don't want to be using any of the game code from that, I think. Or the game shaders doesn't make any sense. Yeah, so you reference a spivvy file shared between other. There we go. Cool. Jobs are good. Right, so renderer changes. We kind of done this, right? We've got 1,000 materials in GPU memory at once at the moment. Like we literally made this change before we started working on this crazy thing. We've got as I saw AMD Toy Shop demo, it was wondering how the hell they do the art direction. Like, I'm not saying I could do any better, but Nvidia seems to have taste that they don't have in their demos. Have you got a link to what you're referencing? I've not seen that. Hey there, Bernie Tech. Sorry, my eyes are so blurry. Yeah, fractal noise generator. We basically made a fractal noise material generator virtual machine shader. So we can basically like put I can expose a piece of UI which allows you to put on a different opcodes, and it will push on noise values per pixel in the shader and make changes to them, and then take the final noise value and then color it in coloring all the different PBR textures based on the noise value. And you can make stuff like this. You can make it makes like a volcanic ground one I've got, and I've got a got like a volcanic ground one that I did first, and then I got like that one. Could be better. I had another one where I put some noise on top of it, like simplex noise. This is like I'm just testing out layering basically, and more layering. So yeah, it's gonna be pretty flexible and awesome. I suppose some UI so non-programmers can, get going and make some materials. And then I have a way for programmers to come in and put some code in and make some materials procedurally. All at build time, not runtime. So you'll be able to spend a lot more time stuff. Path tracing, right. Neural rendering. Man, you seen all this boiling? There's so much damn boiling going on. I just saw it. Unless it's part of the art direction. Can I watch this slowly? Slow motion. Right. I don't know if that painting is meant to be flickering. It's boiling like crap. This was boiling as well, I think. When I saw it there was a bit of a... That looks really noisy on the left as well. Put it to full speed again. Noise, noise, noise! Denoise! I hate noise so much. I'm just trying to... Maybe some of these things are meant to animate bit, but still... That's really noisy on that way right here. And all that. All that. Not a fan. Oh, okay, but it's path tracing, isn't it? So it's gonna. So it's like, hey, this is running in real time. That's the thing about it, isn't it? But you're saying about the art direction. And the TAA sphere and blur, yeah. Yes. Modern day games. But yeah, I don't know, it looks pretty basic. Like, this environment, I think if you take the robots out, the environment doesn't look that bad here. Looks a bit weird though, it looks a bit still. And then you go outside. This looks like some like real life scene. But then like you got these cars which just look a bit weird. Yeah, it doesn't look like stuff fits together, I would say. But yeah. I guess it's path tracing, right? It's pretty cool, but so it's inherently going to be noisy because they're not taking enough samples. But yeah, it's not really like a game. Oh, maybe it's like a game, right? I get noisy results from their rays because not sampling enough. And they fill it in with temporal algorithms, denoisers. Yeah. So yeah, I decided to take a limit of like 1024 unique materials, and the reason why I did this is because I wanted to calculate my MIP level to then know what to load. No, sorry, no, what was it? Calculate the right LOD. So what is the LOD that's been used this frame, and what do I need in GPU memory? And then send that back to the CPU, and the CPU's like, it goes off and loads it from disk when it needs to, and then streams it in, and voila. So there's sort of like a feedback on the GPU, and I did 1,000, and that's because you can fit 1,000 4-byte variables basically, right, in group shared memory, LDS. And when I render the ellipsoids, I'm not using any LDS at the moment, and that will still allow, that will not reduce the amount of work groups that can be switched out when hitting a memory load basically, and it's not in cache. So yeah, it will fit just about enough. Yeah, so I can basically have like the max LODs found for every single material inside a thread group, and do tons of ellipsoids and grab their materials, max the LOD into a group shared memory buffer, and then at the end throw that out into a global buffer, which then gets read back. So that 1024 limit is great for that reason, but it's kind of like, yeah, I wonder if there's gonna be a problem with it later on. So I'm gonna put it on the back burner wherever I want to see if I can remove that or not. But that's the only issue with this. That's the limitation at the moment, I would say. So we have a material cache, and I think the one other issue with this material cache, I think this is the only other problem I've got with this system, is right now all your materials come loaded in together. So we could, like, you've got this layer here on top, this roughness layer, right? If we go to the shader, yeah, we've got this roughness layer now. If I was to sort of just get rid of the roughness layer for a second, let's do a push immediate. And then let's push on an immediate of 0. So it just shows the layer underneath. Right, it doesn't blend in the top layer. So this is what the layer looks like underneath without any roughness applied to it. And I haven't got any normal maps yet, so that's why we're not seeing the other detail. So something you could do is you could have this sort of like base texture. So yeah, it's metallic and there's no normal map basically. So we're not seeing any. It's no roughness, metallic, and yeah, so just it just changes the specular component, doesn't it? Yeah. So something that you could possibly do is you could say when you want to sort of, you could have like a base material, but then later on you sort of come by and add on. You could maybe swap out like another channel with just a different texture from another material that just is like, hey, that one just makes sense. You know, you could have a bunch of different base, like just probably albedo textures or whatever, and you can just put on a bunch of different roughness textures and you get completely different looking things maybe, right? But then they're not, so the power that gives you is like, I've already made a bunch of different assets and I can actually take them apart and configure them. The textures individually. Or I've got this system where a material is designed in the editor, and when it's been designed and compiled out to a list of textures, that is it, there's no changing it. So that's something I'm going to probably think about off stream, is do I split them into a bunch of different textures and I need to sort of change individual parts of a material? And can we remove this 1024 limit? The other thing that I want to do was add scaling and offsetting, because these are very fixed textures at the moment. Imagine if, sorry, these textures are static, right? They do not change. So in the game, when you want to make something react at the material level, it would be nice if we could add some, let's make sure I don't forget this. We want to add probably for each scale and offset properties, scale and offset for each material property. And this will allow us to have a runtime configuration of ways to change the material at runtime basically, but not, it's globally change it, not per pixel. Like the robot in the toy is in the toy shop and gets grumpy because I can't find a battery for another robot, and then in the end the robot goes out, stays grumpy, and goes into dangerous grand park. The fun note is robot is grumpy. I don't know. Yeah. Bit bizarre. Yeah, I was busy looking out for the graphics to realize that, but yeah, it's a bit bizarre. Yeah. Get a bit more interesting, especially going with that sort of setting, I guess. Yeah, so I think this week coming up, Tuesday, Thursday, Sunday, So these next 3 streams, I want to spend at most that time thinking about this again. Like, have we done the right thing here? Do I want to change it? So I think about that off stream actually, and I think I'll probably say about 3 streams that we'll spend on it at most. If not much is going to change because I like what we have, we'll probably just move on quicker to building this material builder. But we're definitely going to add these. So that'd probably take a stream. So the material builder is, yeah, we're just going to create these encode files, which is just my encoder system, which allows you to declare data and it generates serialization code and type info sometimes, depending if you, no, it always generates type info. Oh, that's the thing, there's material palettes as well. We added material palettes so that a model has a palette of materials such that you can skin stuff very easily, which is quite interesting. So, oh yeah, that would still work if we broke the materials apart. But if you could break the materials apart, it means you can add more materials quickly. Yeah. Right. Yeah, so it's basically making the encoder files. There's no implicitly linked. You just found the battery and the other robot comes to life and they dance or something. Yeah, maybe some flashing lights or, you know, just something that makes the scene look more dynamic. It's path tracing after all. Yeah, so I think there's encoder files for all the different types of materials. Material files basically. Editor. Yeah, graphics editor material. I don't know if I should just call these by their file extension name. Because this is like an ED process material. I don't know. Maybe. Think about that. Well, after we've built this sort of code files, it's then building. Sorry, there's files for describing the data layer of the asset files, basically. So we've got some ones for the editor and some ones for when they're baked. Then we have the material builder itself, which basically just loads from those files and runs the shaders. And then we'll save out the material asset file, basically. Probably generate a thumbnail. Check out a thumbnail as well. Simple custom ray tracer that just hits the sphere and it just makes something like this, right? But without this background. That'd be pretty easy to do. I've already got code for that, right? That'd be in the material builder itself, and then create a material builder application which actually just runs the code which is in the library. So it's in the library such that we could probably call it from the editor. Yeah, you want to call it from the editor so it's live and goes directly into memory and not have to go to disk and then back out to CPU memory, then into GPU memory. That'd just be long. Yeah, I don't know if we want to generate, yeah. And then after that, it's basically doing the editor itself. Okay. This is all right. Right, I'm gonna get going and I'm gonna think about these things off stream. Can I, you know, and this is what we'll be working on next week. And then we'll be working on basically getting these materials that we've made and getting them into some asset files. Some for the editor and then some for the actually baked into some assets and stuff like that. All right. Okay, let's find someone to raid. In the meantime, guys, there's Discord if you come and hang out and chat off stream. Appreciate everyone who's supporting the channel. Appreciate you guys. And hopefully you all have a wonderful start to your work week. Alright, let's go and raid this guy, see some assembly. I'm so damn tired right now. I need to eat food and go to sleep. But yeah. Catch you later, guys. Have a good one. In a bit. Bye-bye.